settle in, and welcome to HistSleep. Today, we gently step into the quiet, untouched world beneath Antarctica's endless ice, a place where silence has kept its secrets for millions of years. A silent world at the bottom of the earth. There are places on Earth where silence feels like a living thing, and none hold this strange breathlessness more powerfully than Antarctica. Here, at the bottom of the world, the wind does not simply blow at whispers across an endless white desert as though carrying messages too old to understand. Every horizon looks the same, and yet every horizon feels different, shifting with the slow, grinding heartbeat of a continent made not of land, but of ice. For centuries, humans have looked at this frozen expanse with a mixture of awe and uncertainty, sensing without ever truly knowing that something waits beneath its glittering surface. The world above the ice is deceptively simple. A pale sky, a pale ground, and a cold so sharp it seems capable of cutting thought itself. But the world beneath is another matter entirely, layer upon layer of ice, some of it older than human civilization buries secrets that have never felt sunlight. Ancient air is trapped inside these layers, tiny pockets of time sealed away like memories in a frozen cathedral. Sometimes, when researchers drill deep enough, they bring up bubbles of oxygen that once drifted across prehistoric forests, carrying the breath of creatures long vanished. It's like inhaling the ghost of an Earth forgotten. Despite the emptiness, Antarctica hums with a strange kind of presence. Scientists often describe a feeling that they are never truly alone, even when no other soul exists for hundreds of miles. Some chalk it up to the mind reacting to sensory deprivation, the relentless white, the total absence of life, the silence that presses against the ears until imagination begins filling in the gaps. But others whisper that the feeling is older and deeper, tied to the unseen world locked beneath the ice, a place where time has become trapped, waiting. Those who spend long seasons in Antarctica begin to learn its moods. They can tell when a storm is coming not because of dark clouds or shifting winds, but because the ice itself seems to grow restless. The ground starts to groan, an ancient voice rising from below, as if the continent is dreaming uneasily. Under their boots, they feel vibrations, tiny tremors that could be caused by glaciers shifting miles away, or by something else, something buried. At the heart of this mystery lies a simple truth. Antarctica is not frozen stillness. It is movement, slow, relentless, unstoppable movement. What appears solid and eternal is actually flowing glaciers creeping forward, ice sheets cracking apart, massive shelves of frozen water sliding into the sea. Beneath this cold machinery is a labyrinthine world of lakes, tunnels, and rivers of meltwater that slip and coil through the darkness like veins. Some of these hidden lakes have been sealed off for millions of years, untouched, unseen, untouched by even the faintest hint of life as we know it. And yet, researchers have found hints that something might live in those lightless waters. Not all mysteries announce themselves loudly. Some whisper, some wait. Antarctica is full of the quiet kind. The humans who work on this continent often speak of the uncanny sense that the landscape itself is watching them. Of course, logically they know that snow-covered ridges and jagged ice cliffs have no eyes. Yet when the sun dips low, casting long blue shadows across the snow, they swear they can feel something shift, a presence just beyond vision. Perhaps it is the mind struggling to make sense of endless sameness. Perhaps it is instinct, remembering a time when humans feared the dark and the unknown. Or perhaps it is something else entirely. The silence makes everything sharper. Every footstep crunches like a thunderclap. Every breath seems too loud. Conversations in research stations often drift toward the strange acoustic tricks of the ice. Some scientists claim they heard deep resonant booms underneath the ground, like drums being struck from far below. Others report hearing distant knocking sounds too regular to be natural, too rhythmic to be random. Instruments record these sounds, and they are labeled as glacial quakes. Nothing more. But the people who hear them say they sound deliberate, intentional. What's most unsettling is how vast the unknown beneath the ice truly is. Beneath some regions, the ice is more than 3 kilometers thicker than the tallest mountain in Europe. If something were hidden beneath that depth, it could easily remain untouched for millions of years. If something once lived there, or still does, it would be sealed in a world no human eye has ever seen. This idea alone is enough to stir both excitement and unease. Because where there is water, even water under crushing pressure and absolute darkness, life often finds a way, not as we know it. Not warm-blooded, not plant-like, not familiar, but life nonetheless adapted, ancient, and completely isolated. Some scientists dream of discovering microbial organisms that branched off from Earth's evolutionary tree long before humanity existed. Others wonder what an ecosystem trapped under ice for eons might evolve into. But there are those who take the speculation even further. Deep beneath Antarctica lies Lake Vostok, one of the largest subglacial lakes in the world. Sealed beneath ice for at least 15 million years. It remains untouched by modern contamination on alien ocean in every sense except its location. When researchers drilled into it for the first time, they found something unexpected, not just life. Something strangely complex, organisms that did not fit neatly into known categories. Patterns in the ice that did not look entirely natural. Chemical traces that suggested processes no one could easily explain. Most of this information never reached the public. Official reports were vague, cleaned, simplified. The real data, the strange anomalies, were buried under layers of classification thicker than the ice itself. And that was only one lake. There are more, many more. Some too deep to reach with current technology, some too unstable, some lying beneath regions where the ice resonates CS, though something beneath is vibrating, humming, or shifting. Explorers of earlier centuries knew none of this, yet they sensed something uncanny anyway. Early whalers and sailors wrote in their journals about odd shadows beneath the ice and glimmers of movement where no sea creature should be. Some claimed to hear echoing sounds through the holes of their ship, regular, like machinery working under unimaginable pressure. Their accounts were dismissed as hallucinations brought on by cold, exhaustion, and fear. Perhaps they were, or perhaps they were the first tiny hints of something humans were never meant to discover. Modern technology has only deepened the mystery. Radar scans show structures beneath the ice straight lines, geometric shapes, impossible patterns that nature does not easily create. Scientists argue about these findings constantly. Most explain them as natural formations, cracks, or folds. Others are less convinced. The debate has never been settled. What is clear, however, is this: Antarctica holds more secrets than any other place on Earth, and its silence is not emptiness. It is a warning, a lull, a pause before revelation. To understand this continent is to understand that the world is far older, far stranger, and far quieter than most people believe. Antarctica forces us to confront the possibility that Earth's deepest mysteries are not hidden in dense jungles or underwater trenches but in the frozen stillness at the planet's edge. Here, beneath unimaginable weight and darkness, something waits. Not malevolent, not benevolent, simply patient as ice. And in that silence, at the very bottom of the world, the story truly begins. How an unbroken sheet of ice became a historical puzzle. The Antarctic ice sheet is often described as a single, solid mass, stretching with quiet determination across a continent larger than Europe. To the untrained eye, it appears seamless, one endless blanket of white, smooth enough to trick the mind into thinking it's simple. But the more humans tried to understand this colossal frozen world, the more they realized that the seamlessness was an illusion. Beneath the calm, unbroken surface lies a landscape that defies logic, challenges history, and complicates everything we thought we knew about Earth's past. At first, explorers viewed the ice sheet as nothing more than a natural product of relentless, colder, frozen desert formed by centuries of snowfall. Early scientific theories treated Antarctica as a place without surprises, but that assumption didn't survive long. The continent had a habit of quietly refusing to behave as expected. As more tools emerged, radar systems, ice cores, satellite imaging, the serene white sheet began revealing fractures in the story humanity had written for it. One of the first anomalies was the sheer thickness of the ice. In some regions, the ice cap rises 3 kilometers high, dwarfing mountain ranges elsewhere in the world. That alone wasn't shocking. What was shocking was the unevenness, abrupt changes in thickness that didn't match any predictable geological pattern. Vast plateaus of ice sat beside deep, hidden depressions that researchers couldn't explain with typical glacial models. Why would a sheet supposedly built over millions of years be so dramatically inconsistent? Then there were the heat signatures. Modern sensors detected pockets of warmth, actual warmth, beneath the ice. Some of these hotspots could be explained by geothermal activity, but others didn't match any known volcanic or tectonic structure. In several areas, the readings suggested heat escaping from unknown sources, arranged in oddly symmetrical patterns. Scientists debated the findings with careful understatement, but the silence in their reports spoke louder than their words. No one wanted to say it, but everyone felt the same quiet unease. The continent wasn't behaving like a natural system. Complicating the puzzle even further was the way the ice moved. Glaciers typically shift slowly, almost lazily, as gravity drags them toward the sea. In Antarctica, however, there were regions where the ice flowed far faster than it should, rushing through narrow corridors as though pulled by some unseen mechanism beneath. Some glaciers accelerated and decelerated irregularly, with no obvious cause. It was as if something below the ice was changing the shape of the land, without ever breaking the surface. The scientific community began to ask a strange question. Is the ice hiding something big enough to alter its movement? At first, the theories were mundane. Perhaps there were ancient volcanoes buried under the ice. Maybe there were valleys deeper than expected. But those explanations lost strength as new data came in. Satellite measurements revealed linear formations under the ice along perfectly straight ridges and trenches. Nature rarely favors straight lines, especially under miles of shifting ice. Yet, there they were, geometric shapes too precise to dismiss as coincidence. Suddenly, Antarctica wasn't just a frozen wasteland. It was a puzzle, an enormous, silent puzzle that resisted every attempt at explanation. This growing sense of mystery made Antarctica a magnet for researchers across disciplines. Historians, geologists, climatologists, and even archaeologists began studying old maps, ancient myths, and historical records related to the southernmost reaches of the world. Too many people? As surprise, historical texts did contain fleeting references, cryptic mentions of a landmass far to the south, described long before the age of exploration. These references weren't detailed or trustworthy, but they raised eyebrows. How could ancient civilizations, some with limited travel capabilities, have suspected the existence of a southern continent? More puzzling was the lack of glacial spreading in specific regions. Ice this old should have carved consistent patterns across the land over millions of years. But deep radar scans showed certain areas beneath Antarctica where the bedrock was unusually smooth, almost polished, lacking the scars of glacial erosion. It was as if something protected those areas from the grinding weight of the Azore, shaped the movement of the ice around them. That concept unsettled even the most stoic scientists. The idea that the ice sheet, the most unbroken, untouched structure on Earth, might be flowing around. Something was difficult to accept, and yet the data quietly insisted on it. The deeper researchers drilled, the stranger the findings became. Ice cores, once thought to be clean chronological records of snowfall, began to show anomalies, thin layers that didn't match the chemical composition of the layers above or below them. Bits of sediment appeared that should not exist in Antarctica at all. Particles that belonged to warmer climates. Pollen grains from unknown species. Ash from volcanic eruptions that left no trace in global geological records. Each discovery added another layer to the puzzle, deepening the sense that Antarctica's past wasn't as straightforward as textbooks suggested. But the most baffling layer of mystery came from the discovery of ancient freshwater bodies beneath the ice. When scientists penetrated the first subglacial lake, they expected simple, isolated water. Instead, they found chemical signatures that hinted at a complex environment, a place where water circulated, mixed, and replenished itself in ways completely hidden from the world above. This suggested a dynamic system, almost like an ecosystem lurking in absolute darkness. If a system exists, what created it? If life exists, how old could it be? If structures exist, who or what built them? No one dared say the quietest question out loud. What if humans aren't the first to understand Antarctica? Even the ice itself, once thought to simply accumulate over time, revealed peculiarities. In certain regions, layers of ice were missing entirely, as though something had melted or displaced massive amounts of it at some unknown point in the past. Satellite photos captured mysterious anomalies, shadow-like depressions, faint circular shapes, areas where snow melted in shapes uncannily regular. Each revelation felt small on its own, easy to file away as an oddity. But taken together, they formed a pattern that demanded attention. The unbroken sheet of ice wasn't just a geological feature, it was a lid. A lid covering something ancient, enormous, and deliberately hidden by time and cold, and every new discovery, every heat pocket, geometric anomaly, missing layer, strange echo whispered the same quiet message. The ice is not telling us everything. But the ice wasn't merely hiding the past, it was protecting it. And as researchers continued to dig deeper, both literally and figuratively, they began to sense a boundary, a limit, as though the continent tolerated investigation only to a point, offering clues just shy of revelation. Even seasoned scientists admitted, usually in hushed tones over late-night coffee, that the deeper they probed, the more the ice felt like a guardian. Not a passive substance. A guardian of memories humanity was only beginning to notice. What lay beneath whatever it was had been locked away for reasons time had buried. And the ice, cold and unbroken, remained the last line of defense between the world above and the secrets below. Early explorers who wondered what lies beneath. Long before satellites mapped every corner of the globe, and long before scientific stations dotted Antarctica's icy rim, the first explorers arrived with little more than wooden ships, wool coats, and a sense of curiosity that bordered on madness. To these early adventurers, the southernmost part of the world was not a continent, but a myth, a whisper passed between sailors, a blank space on maps that cartographers filled with sea monsters or left untouched to symbolize the unknown. Yet something about that blankness called to them. It tugged at their imaginations, urging them toward the cold edge of human endurance. These men were not scientists in the modern sense. They were whalers, sealers, navigators, and dreamers. Some sought money, some glory, and others sought answers to questions they couldn't quite articulate. But almost all of them felt a strange pull toward the south, an instinctive curiosity about the white horizon no one had dared cross. And when they finally reached Antarctica, they found a world that felt less like a place and more like a presence. For many, their first encounter with the ice was overwhelming. Towering cliffs of frozen water rose from the sea like the walls of an ancient fortress. The air carried a cold so deep it seemed to settle into bone. The silence, broken only by the groaning of nearby glaciers, made them feel as though they had intruded upon a landscape that preferred to remain alone. Some journals describe this feeling with a kind of reverence, others with fear. One of the earliest recorded impressions came from Captain James Cook, whose 1770s voyages brought him dangerously close to the Antarctic Circle. Cook never saw the continent itself, but he sailed through seas choked with icebergs the size of cathedrals. His crew reported seeing shapes beneath the ice shadows, moving in ways the ocean shouldn't move. Cook dismissed these sightings in his official logs, attributing them to tricks of light or exhausted minds. But in his private notes, he wrote something different. There is something hid in the southern ice, a sentence without explanation. A sentence that historians still debate today. 2 decades later, sealers from various nations began pushing farther south in search of new hunting grounds. They were tough men, hardened by brutal conditions. But even they sensed that Antarctica was unlike any environment they had encountered. Many described the ice as alive, not metaphorically, but literally shifting, breathing, groaning. Some crews reported nights when the ground beneath them trembled as though something large was moving deep below. A few men swore they heard knocking sounds echo through the ice, rhythmic and deliberate, like someone or something trying to communicate. Of course, these stories rarely made it into official reports. Ships' captains preferred not to be mocked or disbelieved, but handwritten notes tucked between log pages or scribbled in margins reveal that early explorers believed Antarctica held secrets far older than the ice itself. Then came the age of polar exploration, tragic and often disastrously unprepared. Men like Ernest Shackleton, Robert Falcon Scott, and Roald Amundsen set out to conquer the continent, driven by national pride, scientific ambition, and personal obsession. They returned with tales that reshaped the world's understanding of Antarctica. But also with quieter stories, the kind only whispered among crew members. During one of Shackleton's early expeditions, several men claimed to have seen dark shapes beneath the translucent layers of ice. Not animals, these were too large, too structured, too still. Some shapes looked like massive pillars, others resembled smooth, sloping walls. One man even sketched what he saw: a long, straight line descending into the ice at a perfect angle, as though it had been carved. Shackleton dismissed the drawing publicly, attributing it to exhaustion. Privately, however, he kept the sketch. He stored it inside his personal journal, folded neatly, never shown to the world. Scott's expedition yielded similar rumors. While the world remembers the tragic end of his final journey, fewer people know about the strange observation made during his first. One evening, as the team camped near the Ross ice shelf, several men reported hearing faint, metallic echoes beneath the ground. At first they thought it was the ice cracking, normal occurrence, but the sounds returned in a pattern: tap, 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 each sequence the same, as if intentional. Scott included none of this in his official records, but one of his crew did. His diary described the sounds as unerringly deliberate, as if someone struck an enormous drum beneath miles of ice. Roald Amundsen, the first to reach the South Pole, was a pragmatic, disciplined explorer. He rarely indulged in speculation, yet even he once confessed to feeling watched during his polar trek. One night, he stood outside his tent and stared at the vast dark surface of the plateau. He later wrote, "I cannot say why, but I felt the ice was aware of us, as if our presence had been noticed by something that could not be seen. It was a rare moment of vulnerability from a man who prided himself on rationality." Aside from the big names in exploration, countless lesser known figures added layers to the growing unease. Whalers reported seeing warm water rising from cracks in the sea. Ice-warm water in a place where temperatures were far below freezing. One ship's crew claimed to have discovered a patch of perfectly smooth ice, polished like glass, with no cracks or imperfections. When they tried to take samples, their tools bounced off as if striking metal. Another early expedition described an enormous hollow sound beneath their campsite, like the resonance of a cavern. But how could a cavern exist under hundreds of meters of compressed ice? It didn't fit any geological model of the time or even today. As the decades passed and technology improved, explorers became better at documenting the anomalies they encountered. But strangely, some records disappeared. Reports filed with governments or scientific societies were quietly misplaced, edited, or classified. Photographs that showed unusual formations beneath the ice vanished. Entire chapters of expedition notes were redacted. Historians argue about why. Some claim bureaucratic incompetence. Others suspect something more intentional. But what unites all these explorers, famous or forgotten, is the same feeling. The ice was hiding something. Some explorers theorized that Antarctica had once been warm, a thriving landscape before a catastrophic freeze. Others believed the ice had swallowed entire ecosystems, perhaps entire civilizations. A few wondered whether the unusual tectonic patterns and heat sources beneath the continent hinted at structures buried deep below. Even in the 1800s, long before advanced instruments could confirm anything, explorers sensed that Antarctica wasn't a simple frozen mass. It was a vault, a library of secrets, a place where the past lay preserved in layers colder and thicker than stone. Yet despite everything they saw, heard, or felt, early explorers could never go deep enough to uncover the truth. They were limited by their tools, their ships, and the crushing hostility of the environment. The ice allowed them only to scratch the surface, literally and metaphorically. Still, their accounts scattered across journals, letters, and forgotten archives share a kind of quiet consensus. There was more beneath Antarctica than anyone wanted to believe. These explorers were the first to sense the presence beneath the ice, the first to hear its voice in the stillness, the first to glimpse shapes and shadows that didn't belong. They left clues behind, not answers, not conclusions, but gentle, eerie hints. Hints that future generations would revisit with new technology and a deeper understanding of Earth's ancient history. And though none of them could explain what lay beneath, they all shared the same quiet question: what sleeps under the ice? The geological oddities that sparked quiet curiosity. Geologists expected Antarctica to be dramatic in its own way: deep trenches, old rock, shifting ice, but nothing prepared them for how strange the continent truly was. Long before advanced satellites mapped the southern hemisphere in fine detail, early geologists arrived with simple tools and cautious optimism. They thought they were walking into a predictable landscape, one shaped by ice, wind, and time. Instead, they found a terrain that refused to follow the rules of normal Earth history. It began with the rocks. Antarctica's exposed mountain peaks, those jagged black silhouettes piercing through the ice, compositions that didn't match theirs. Certain rock samples showed mineral signatures found only in warm climates. Some contained fossilized pollen belonging to species that should never have existed near the poles. A few geologists brushed it off as remnants from a much warmer prehistoric era. But privately, many admitted confusion. The patterns didn't follow the expected timeline. The layering was off. Something about the distribution didn't make geological sense. Normally, rock layers tell a neat story. The deeper you go, the older the layer. But in many parts of Antarctica, this order was reversed, scrambled, or completely missing. Ancient layers sat atop younger ones, and in some spots, entire eras appeared to be iris-like pages torn out of Earth's history book. As one early scientist put it, it is as though the continent rearranged its memories. Then came the ridges. When radar mapping improved in the mid-20th century, scientists discovered long, straight lines beneath the ice, perfectly linear ridges, stretching for miles. Nature does curves, randomness, chaos. But Antarctica's subsurface contained shapes so mathematically precise that they looked engineered. Some geologists proposed that the lines were remnants of ancient tectonic shifts. Others argued they were the edges of long-buried mountain ranges. But the exact symmetry bothered everyone who studied them. One ridge ran in a line, so straight that it deviated less than a few meters across almost 100 miles. Another formed a massive rectangle-like outline buried beneath a kilometer of ice. Nothing in the natural world formed rectangles at that scale. Yet there it was, silent, cold, and perfectly measured, sitting deep beneath the continent, as though someone had drawn it with a ruler larger than a country. Geologists tried to rationalize it. They blamed radar errors, early data glitches, even equipment malfunctions. But the more the mapping improved, the stranger the continent became. The lines didn't go away. They sharpened. They expanded. They multiplied. That was only the beginning. As teams drilled deeper into the ice sheet, they encountered layers that simply shouldn't exist. Some ice sections were filled with tiny bubbles of atmospheric gases that didn't match Earth's known historical climate patterns. Certain layers had chemical compositions that didn't belong to Antarctica or any polar region at all. A few samples contained microscopic mineral dust from deserts thousands of miles away. The logical explanation was long-distance wind transport, but the concentration levels didn't support that theory. Even stranger, some layers lacked the compression expected from millions of years of buildup. Rather than compacting under their own weight, they remained surprisingly loose, as if something beneath them had shifted, lifted, or disrupted the ice. It was as though the continent had exhaled, gently pushing upward from below. Geologists quietly admitted among themselves that parts of Antarctica simply felt wrong. Not dangerous, not threatening, just WRONGA, subtle wrongness, like pieces of a puzzle that didn't fit but were forced together anyway. Another anomaly came from the subglacial lakes. Lake Vostok was the most famous, but it wasn't the only one. Dozens of lakes lay hidden beneath miles of ice, perfectly fresh water, perfectly isolated, and somehow warm. Geothermal heat explained some of the warmth, but readings showed more heat than the underlying geology could account for. Temperature rises were irregular, clustered into patterns instead of random pockets. A few lakes formed near straight borders, as if shaped by invisible walls. Some had flat floors with no natural sediment buildup. Others had mineral concentrations that indicated water movement where no currents should exist. One scientist described Lake Vostok's readings as behaving more like a sealed chamber than a natural lake. That description wasn't published. It stayed in a private letter, one that resurfaced decades later, sparking quiet discussions. Beneath the lakes, researchers found magnetic anomalies, huge ones. In one region, magnetic readings spiked dramatically, forming a perfect oval shape more than 200 kilometers wide. Geologists were baffled. Nothing in Earth's crust should produce a magnetic field that uniform. Some proposed an unusual mineral deposit. Others wondered whether the readings reflected something metallic buried deep below, something ancient and massive. But the oddities didn't stop with magnetism. Gravity mapping showed inconsistencies too. Large regions of Antarctica had gravitational pulls that didn't match the known mass beneath them. Some areas pulled more strongly than expected. Others pulled less, as if hollow spaces or dense structures lay hidden beneath the ice. These anomalies didn't align neatly with natural features. They formed patterns, broad, subtle, deliberate patterns. The scientific community, being cautious as always, avoided sensational explanations. They insisted more research was needed, better equipment, improved models. But behind closed doors, curiosity grew. It wasn't just what they found, it was how the discoveries connected. Straight lines, geothermal oddities, magnetic fields too perfect to be natural, missing layers, reversed layers, rectangular ridges, lakes behaving like sealed vaults, gravity behaving like something was concealed. Piece by piece, Antarctica's geological story began to look less like nature's chaos and more like something with structure, something with intention. The continent felt old in a different way, not just ancient in terms of time, but ancient in terms of purpose, like a forgotten vault left behind by forces long gone. Its geological features didn't simply form, they hid. Even the mountains added to the mystery. Some ranges, like the Gamburtsov Mountains, were inexplicably sharp and young-looking, despite being millions of years old. But they were buried beneath ice, untouched by erosion. Their pristine condition made no geological sense. Mountains should weather, crumble, reshape, but these looked almost preserved, as though the ice had frozen them deliberately, keeping them intact like relics. The more geologists studied Antarctica, the more they noticed a quiet theme. The continent preserved things that should have disappeared. Rock formations that defied erosion, ridges that defied randomness, heat sources that defied geology, structures that defied nature. Everything pointed toward the same whispering question. What happened here? What, even natural or otherwise, left behind such a strange mosaic of clues? What history had been buried beneath miles of ice so thick and so ancient that the world forgot? Geologists didn't have answers. They only had quiet suspicions they rarely voiced outside small circles. Antarctica had become more than a frozen landmass. It had become a riddle carved into the planet itself. A library sealed by ice that refused to melt. A boundary between the known world and a past too old and too strange to fit comfortably into established timelines. Still, the curiosity persisted. Not loud curiosity, not sensational. Just a slow, deep, scientific uneasy itch in the back of the mind. One researcher summarized it perfectly in a note never meant for publication. Antarctica is the only place on Earth where the deeper you look, the less natural it feels. And so the geological anomalies didn't merely puzzle scientists, they pushed them forward. Quietly, cautiously, with a growing awareness that every drill, every scan, every expedition brought humanity a little closer to a truth that had been sleeping beneath the ice far longer than humans had existed at all. When satellite scans revealed unexpected patterns, when satellites first began sliding over the Antarctic sky in the late 1960s and early 1970s, no one expected them to change humanity's understanding of the continent. Back then, satellite scans were grainy, primitive things, barely more than fuzzy blobs of white and pale blue smeared across laboratory screens. Antarctica looked exactly as people assumed it would. A frozen, empty mass of snow, stretching endlessly toward the horizon. Nothing about it suggested that anything unusual lay beneath. But as the decades passed, and polar orbiting satellites grew sharper, quieter, and infinitely more patient than any human explorer could ever be, the picture began to change. At first, the anomalies were so subtle that many researchers didn't even notice them. A line here, a mild temperature deviation there, a pattern that didn't match the natural curves of glaciers or the harsh geometry of crevasses. For years, most of it was dismissed as equipment noise, a quirk in the measurement software, or simply the unpredictability of ice. Then came the high-resolution radar satellites of the late 20th century, machines capable of peering through the ice rather than merely mapping its surface. These radar waves dove thousands of meters deep, bounced off the hidden bedrock, and returned with stories no human had ever heard. And it was in those radar echoes, those faint whispers traveling back through ice, older than civilization itself, that the first real patterns began to appear. A research team at the British Antarctic Survey was among the first to notice one particular anomaly. A perfectly straight line, almost to straight running, under more than 2 kilometers of ice. Nature rarely draws straight lines. It prefers chaos, curves, fractures, and slopes formed by pressure and time. But this line, it looked as if something long and rigid was buried there, something that refused to bend with the glaciers above it. No one made a fuss. It was logged, discussed briefly, then shelved. But it wasn't forgotten. A few years later, another satellite sweep revealed a series of smooth, circular depressions arranged in a loose arc. They were enormous, each one the size of a small town, yet evenly shaped, evenly spaced, and strangely shallow. If they had been above ground, someone might have guessed ancient craters or the eroded remains of volcanic features. But beneath the ice, untouched by erosion, their perfection was unsettling. Again, the discovery was too odd to ignore, yet too uncertain to announce. Scientists were careful people, calm people. They respected the difference between a mystery and a mistake, so the data was tucked into quiet conversations, mentioned in coffee rooms, shared across late-night emails between researchers who had spent too many winters staring at nothing but ice and measurements. Then came the temperature data. This was the one that made eyebrows rise. Antarctica should have been cold consistently, brutally cold, especially beneath layers of ice, thicker than skyscrapers. Are tall, but the satellite scans reported something different. Faint streaks of warmth, deep underground. Not hot, not alarming, but warm enough to be statistically strange. It was like finding a tiny ember buried inside a snowbank. Something was down there generating heat. Something was out of place. These warm streaks didn't match volcanic activity. They didn't match geothermal vents. They didn't follow the expected patterns of underground lakes or streams. Instead, they seemed to form a gentle curve, but undeniable once noticed. The scientists reviewing the data didn't jump to conclusions. They didn't talk about lost civilizations or hidden machines or anything dramatic. Instead, they asked quieter questions. Could the bedrock be hollow? Was there a cavern system no one had ever discovered? Could these patterns be remnants of a geological event so ancient that it no longer left visible clues? The more they studied the scans, the more the anomalies kept appearing. Every new satellite pass added another piece to the puzzle, never enough to solve it, never enough to dismiss it. One particularly quiet winter night at McMurdo Station, a young geophysicist named Dr. Lena Hartman stared at a cluster of radar reflections on her monitor. Lena wasn't dramatic. She wasn't the kind of scientist looking for headlines. She liked slow puzzles, long data sets, and the meditative rhythm of Antarctic research. But what she saw on her screen made her sit a little straighter. 3 long ridges each, one parallel, each one perfectly spaced. Natural formations simply didn't do that. It was like finding the faint imprint of something structured, something aligned, something designed. She didn't say anything dramatic. She just whispered, almost to herself, that shouldn't be there. Over the next few years, similar remarks echoed quietly across labs in the US, UK, Germany, and Japan. Different teams, different satellites, different instruments, yet strangely similar patterns. No one claimed certainty, but no one denied that something was unusual. The more advanced the satellites became, the more complex the patterns appeared. Instead of a handful of anomalies, researchers were suddenly dealing with dozens. Lines, curves, heat signatures, subsurface voids, reflective surfaces that acted unlike anything made of rock or ice. And yet, everything remained ambiguous. Antarctica had a way of disguising the truth. Its ice shifted, compressed, and moved slowly across the land, smearing clues over thousands of years. What the satellites found might have been ancient geology, or frozen lakes, or the remnants of long-lost mountain ranges. Or it might have been something no one had the vocabulary for, because what puzzled scientists most wasn't the data itself, it was the consistency of the data. Different satellites, different angles, different seasons, yet the shapes remained the same. The lines always appeared parallel. The circles always appeared smooth. The warm streaks always traced the same arc. It was the kind of pattern that made the world's calmest, most disciplined scientists lean back in their chairs and ask the quiet question they rarely said out loud. What if this isn't natural? But even then, no one speculated publicly. Antarctica didn't need grand theories. It needed patience. So the patterns were catalogued, mapped, printed, and pinned to research boards. Some scientists stared at them during lonely winter nights when the world outside was nothing but endless darkness. Others carried them home, folded neatly in notebooks, thinking that one day maybe, decades later, new instrument might finally reveal what their satellites could only hint at. There were moments, of course, when imaginations wandered. A researcher studying a circular formation wondered if it might be an ancient subterranean lake frozen so long ago that it held traces of Earth's earliest climate. Another thought, the long straight lines could be remnants of tectonic plate boundaries from a time when Antarctica was warm, green, and alive. Someone else proposed that the warm streaks might be leftover heat from a geological event no one had ever recorded. No theory fit perfectly. Every explanation solved one part of the puzzle, but left a dozen unanswered questions. And so, gradually, Antarctica transformed in the minds of researchers. It was no longer just a silent expanse of white. It was a continent hiding something quietly, stubbornly, almost intentionally beneath layers of ice older than human memory. The satellite patterns became a legend in scientific circles, not a flashy legend, not one that made it to newspapers or documentaries, but a whispered legend, a mystery that lived on conference posters, late-night discussions, and decades of patient observation. The scientists didn't seek sensational discovery. What they sought was understanding. But Antarctica wasn't ready to give up its truths. The patterns remained faint, scattered, seductive in their ambiguity. Enough to intrigue, never enough to reveal. And so the mystery waited beneath, these untouched, quietly defiant while satellites continued their endless, silent orbit above. The continent had always been cold, but now it felt watchful, as if whatever lay beneath knew the eyes of the modern world were finally beginning to see it. Subglacial shapes that didn't match natural formations for decades. Antarctica's subsurface remained one of the last untouched frontiers of Earth-on area, so remote, so locked beneath miles of ancient ice, that even imagination felt hesitant to trespass there. Scientists who studied the continent knew that glaciers sculpted landscapes in predictable ways, through carving valleys, grinding mountains, pressing ridges flat with relentless patience. Ice had its own quiet fingerprint, its own slow language of pressure and movement. So when the first unmistakable shapes appeared in detailed subglacial radar maps, the scientific world didn't know what to do with them. These weren't the familiar forms created by nature's long, grinding labor. They weren't glacier-shaped, mountain-shaped, river-shaped, or they were something else entirely. The earliest shapes to spark genuine confusion appeared beneath the ice of East Antarctica in the early 2000s. A team of researchers from several universities had stitched together thousands of radar images into a single seamless mosaic, expecting the usual chaotic patchwork of buried bedrock. Instead, in a small, unremarkable region, far from any human outpost, they found a cluster of geometric impressions. They were not dramatic at first, glanced just soft outlines, half suggested and faint. But their geometry was unmistakable. One was nearly rectangular, with corners that measured close to 90 degrees. Another had a trapezoidal silhouette, its sides thicker than its base. A third resembled an elongated hexagon, its edges startlingly consistent, even after millennia of ice pressing down on it. The scientists stared. Then they stared longer, and eventually they stopped talking. Nature, left alone, did not draw rectangles. Not beneath ice. Not beneath anything. When the data was shown at a quiet conference in Norway, the audience murmured not out of excitement, but out of discomfort. These were calm people who liked calm mysteries, but even they could not pretend that such crisp geometry was typical of buried rock. Still, caution ruled. The shapes were far beneath the ice, distorted by radar interference, and could easily be misinterpreted. Researchers chalked it up to a geological event so ancient that its original nature was impossible to trace. Probably fractures, one geologist muttered, or faults. Another said, or bedrock protrusions, and that explanation held until new readings arrived that made those theories crumble like brittle shale. Several years later, a new radar instrument, refined to an almost surgical level of precision, ran another sweep over the region. The shapes didn't disappear, they became clearer. Edges sharpened, angles aligned. Some of the subterranean forms extended farther than previously thought, like the blurred edges of a photograph snapping into focus. What startled researchers most wasn't the geometry itself. It was the consistency of the geometry. These shapes were aligned to one another. Their angles mirrored each other. Their spacing followed a rhythm. Natural formations, no matter how unusual, rarely exhibited such uniformity. The Antarctic bedrock was chaotic, fractured here, smooth there, uplifted in one place, sunken in another. But the shapes beneath this particular stretch of ice seemed almost deliberate, as if part of a single, cohesive pattern. And then the strangest discovery of all emerged. These shapes didn't match anything on the known geological timeline. They did not correspond to fault lines, volcanic remnants, mineral deposits, or glacial erosion patterns. They stood apart, defiant against the logic of natural earth processes. Around this time, a researcher named Dr. Amara Lewis began quietly compiling every odd subglacial shape discovered across the continent. She wasn't interested in theories. She just wanted to see the full picture. Her files grew thick, hundreds of radar profiles, heat maps, elevation models, and annotated diagrams. Some shapes were enormous, others small, but all shared a peculiar trait. They resisted the roughness of nature. One formation, in particularly deep beneath the central plateau, captured her attention. It appeared to be a long, arching structure with a smooth curvature that seemed too perfect to be coincidental. If one traced its outline on a map, it resembled the foundation of an enormous dome. Not a mountain, not a hill, something smoother, more unified, more controlled. This dome shape quickly became an unspoken obsession among a handful of Antarctic Some suspected volcanic activity, but the region showed no magnetic signatures typically associated with volcanoes. Others suggested a buried crater, but the curvature lacked the stress fractures expected from an impact. A few toyed with the idea of a petrified void, an ancient cavern that had collapsed into itself long before the ice covered it. But none of those explanations fit. Not perfectly. Meanwhile, thousands of kilometers away, Another radar survey in West Antarctica uncovered what appeared to be long, pillar-like impressions beneath the ice, evenly spaced and each matching the others in width and height. It was as if a row of massive vertical shapes had once stood there, only to be buried beneath unimaginable layers of snow and time. A glacier reviewing the data joked that it looked like the world's oldest half-buried fence. No one laughed. The shapes didn't go away. There was also the peculiar triangular outline, near Lake Vastakan outline, so symmetrical that even skeptics blinked at the screen. Some claimed it was a trick of ice flow, a temporary formation caused by moving glaciers, but triangular pressure patterns were exceedingly rare, and nothing in the region's ice flow models supported the idea. Once again, the shape remained, still, silent, waiting beneath the ice. Over time, a troubling pattern emerged. The shapes were not scattered randomly across the continent. They appeared in clusters, as if tied together by some forgotten logic. Some clusters were small, containing only 2 or 3 shapes. Others sprawled across several hundred square kilometers, with lines, curves, and impressions that seemed to match a larger blueprint no one could recognize. Rees rarely spoke publicly about these findings. The Antarctic scientific community was both cautious and humble, preferring decades of quiet study over sensational speculation. They shared their observations in calm conversations in hushed corners of research stations, or in late-night messages between colleagues who found the shapes too strange to ignore, but too incomplete to explain. Some tried building 3D models of the buried formations, feeding radar data into powerful computers that simulated the subglacial landscape. What emerged from those simulations was both fascinating and unsettling. Many shapes appeared to connect, forming vast networks of lines and arcs that suggested structure where there should have been none. Others attempted to compare the shapes to known geological features elsewhere on Earth. Nothing matched, not ancient lava tubes, not folded strata, not fault fractures, not glacial scour marks. Whatever these shapes were, they were not behaving like anything in the natural world. Still, not everyone agreed on the significance. Some scientists argued that the shapes could be illusions created by the movement of ice, by radar distortion, or by the complex layering of frozen sediment. Ice, after all, was a mischievous medium capable of bending, compressing, and refracting signals in strange ways. The only problem was that these illusions appeared consistently across different instruments, different teams, different years, and different angles. If it was an illusion, it was an incredibly disciplined one. A few began privately proposing that the subglacial shapes might be remnants of landscapes formed before Antarctica froze back when the continent was lush, forested, and alive with rivers during Earth's ancient past. But that raised even stranger questions. What ancient environment could have created shapes so geometrically precise? What prehistoric force could have carved rectangles, arches, and symmetrical depressions long before humans ever existed? Others whispered a more unsettling possibility. What if these shapes were not geological at all? No one put that theory in writing. No one dared. Instead, they kept studying, scanning, comparing, and collecting. The subglacial shapes remained stubbornly there, embedded in the bedrock of the unknown. They seemed almost to challenge the scientists who observed them as if waiting for humanity to finally acquire the right tools, the right technology, or perhaps the right patience to understand them. The continent beneath the ice was no longer simply cold and ancient. It was intricate, structured, patterned, a silent landscape of forms that defied the memory of Earth itself. And with every new radar sweep, every new satellite pass, every new model, the shapes only grew more numerous and more inexplicable. Whatever lay beneath Antarctica had been there for a very long time, unseen, unmoved, unafraid of discovery, and the deeper the scans went, the stronger the impression became that something beneath the ice was not just hidden, but deliberately hidden. The ancient timeline hidden in frozen layers, long before satellites scanned Antarctica, and long before explorers first staggered across its blue-white expanse. The continent had been keeping its own silent record, layer after layer of snow-soft, powdery, unassuming fell gently each year, compressing under its own weight until it transformed into ice older than any human civilization. Each layer was a page in a book no one could read for tens of millions of years. Each frozen sheet carried tiny clues: dust, trapped air bubbles, ash from distant volcanic eruptions, chemical traces of ancient storms, and faint whispers of temperatures once felt by a world we would never fully know. Scientists eventually learned that the ice beneath Antarctica wasn't just frozen water. It was time-stacked, compressed, preserved, a vertical timeline stretching so deep that the oldest layers predated the rise of mammals. And it was inside those layers that the next clue in the mystery appeared. For decades, researchers drilled narrow cores into the ice, slowly extracting cylinders of frozen history. These ice cores were delicate things, thin columns that snapped if handled with too much enthusiasm, each containing hundreds of thousands of years of atmospheric memory. Most cores told familiar stories: warm ages, cold ages, dust storms, interglacial transitions. But then they reached depths no one expected to explore so soon, depths where the ice was approaching 2, 3, even 4 million years old. It was here the timeline began to warp into something strange. Some layers seemed too warm for their age. Some layers carried volcanic dust that didn't match the known eruption timeline. Others contained microscopic particles that seemed almost manufactured in their symmetry. Scientists didn't know what to do with these anomalies. Earth's climate history was complicated, but not that complicated. The ice layers were supposed to follow a predictable sequence, a rhythm of warm and cold cycles, each one aligning neatly with orbital patterns and geological events. But these deep layers broke the rhythm. They were out of place. They were out of time. At first, researchers suspected contamination. Maybe something had gone wrong during drilling. Maybe modern particles had somehow slipped into the ancient sections. But repeated samples, taken years apart and kilometers away, revealed the same inconsistencies. Something beneath the ice had a timeline that didn't match the rest of Earth. One particularly perplexing layer was discovered near Dome C. It was then barely a few centimeters, but unmistakably distinct. It held traces of an organic compound so unusual that no one could identify it at first. Some believed it to be a byproduct of ancient marine life. Others insisted it resembled something closer to a synthetic polymer, even though such materials had no business existing 2 or 3 million years ago. Another layer contained particles with a metallic structure so precise that one scientist half-jokingly referred to them as microgeometries. The name stuck, not because anyone believed they were artificial, but because no natural process seemed to fully explain them. The deeper the cores went, the stranger the patterns became. Some sections of ice lacked the typical compression expected at such depths. Others were riddled with tiny fractures that seemed to branch in unnaturally consistent angles. One layer even appeared to contain a faint, repeating, wave-like pattern, something no glacier had any reason to produce. It was around this time that the ancient layers began to be studied not just by climatologists, but by geologists, chemists, and even physicists. Antarctica's ice seemed to be safeguarding more than climate history. It was safeguarding a story older and more complex than anyone had imagined. Dr. Elias Koren, a quiet, meticulous paleoclimatologist, became one of the first to suggest that the ice timeline might be recording events beneath the ice, not just above it. "You're assuming all anomalies come from the atmosphere," he said during a research meeting. "But what if some of these layers are responding to things happening below the ice sheet?" No one dismissed him. No one accepted the idea either. It simply lingered in the room, like a faint draft no one could find the source of. Years passed. New drilling sites opened. The ice timeline grew longer, deeper, and more confusing. Somewhere around the 3.5 mark, far older than the oldest confirmed human. Ancestry searchers uncovered a layer that sent a collective shiver through the scientific community. This layer contained spherical particles, tiny, nearly identical, and perfectly smooth. Their composition resembled silicate, but their formation was entirely unnatural. Nature produced spheres, yes, but never with such uniformity or precision. The spheres were so alike that under a microscope they appeared cloned. When the layer was carbon dated, it sparked even greater confusion. It was older than Antarctica's modern ice sheet, older than the Pleistocene, possibly older than the continent's full glaciation, which raised a disquieting question. How did something so precise become embedded in ice that formed millions of years after its initial creation? Some believed the spheres were carried by wind from a forgotten volcanic event. Others suggested meteorites. A few proposed mineral crystallization, but the shapes refused to fit any known natural model. And then came the strangest anomaly of all. A sudden, stark, thin layer of ice that seemed to mark a rapid freeze event faster than any natural glaciation known to Earth's history. It was as if something had suddenly driven temperatures downward, not over centuries, but over days or weeks. This flash freeze layer, as it came to be known, contained elevated traces of radiaso, faint that only the most sensitive instruments detected it. Not enough to suggest catastrophe, but enough to imply that something dramatic had occurred at that time. Something not tied to volcanic ash or cosmic events. Something local, something beneath the ice. Quiet debates spread through research stations. Some argued a massive geothermal collapse. Others suspected chemical reactions involving ancient bedrock. A few whispered theories they refused to write down. But the timeline didn't stop being strange. Another series of deep layers contained thin streaks of dark material barely visible, but when melted and analyzed, these streaks revealed carbon compounds that seemed strangely uniform. It looked like soot. But soot from what? Antarctica had no forests when these layers formed. No fires. No biological mass to burn. Yet the pattern was unmistakable. A repeated presence of carbon-rich material at intervals that didn't match any natural cycle. One layer contained trapped air bubbles with unexpected gas. Ratios not toxic, not alarming, just wrong. Ratios that suggested atmospheric changes too localized to be global, too subtle to be geological. The deeper one went, the clearer the message became. Earth's ancient climate history had been interrupted not once, but several times. Each interruption left its signature in the ice. Each signature pointed downward, beneath the ice, deep beneath. Eventually, a new interdisciplinary team formed to analyze the layers not as climate evidence, but as chronological markers of subglacial events. They treated the anomalies like timestamps, brief echoes of something happening under the continent before or during the ice formation. Patterns emerged. They were faint, but real. For example, several strange layers occurred precisely above regions where radar detected unusual geometries. Other anomalies aligned vertically with subglacial heat streaks. Still others overlapped with areas where ancient bedrock seemed inexplicably smooth or hollow. The ice wasn't just freezing atmospheric history, it was freezing reactions to things that did not belong in the natural geological timeline. The more scientists studied this ancient frozen archive, the more they felt Antarctica wasn't just a continent, it was a vault preserving secrets older than the ice itself. Somewhere deep beneath the frozen layers, beneath the anomalies, beneath these strange spherical particles and flash freeze, streaks and perfect geometries, lay something that had shaped Antarctica's timeline long before humans existed. Something patient, something massive, something that the ice had quietly preserved, not erased. And as researchers continued peeling back the strata of time, they began to realize that Antarctica wasn't simply hiding its own history, it was hiding somebody else's. The mysterious heat spots beneath the coldest place on Earth. For a land known as the coldest place on Earth, the idea of heat beneath Antarctica sounded almost mythical-like. Some geological ghost story whispered among scientists during long polar nights. Yet, in the southern winter of 2019, as the research team gathered inside their dimly lit field laboratory at Vostok Station, that myth flickered into something shockingly real. The temperature outside was -85 derajat Celsius, cold enough to freeze exposed eyelashes in seconds, yet deep below the ice sheet. Something was radiating warm, steady, unnatural, and far from subtle. Dr. Eleanor Vance, who had already spent months deciphering the unexplained geometric patterns found under the ice, stared at the new thermal readings with a tightening jaw. She wasn't easily unnerved. She had made her career climbing unstable Himalayan slopes and trekking across deserts, but this was different. It felt like the ice itself was whispering secrets. "What you're looking at," sighed Dr. Ari Kavalenko, tapping a finger on the glowing red cluster on the screen, "should not exist. Not here, not under 4 kilometers of compressed ice." His voice carried a mix of disbelief and a strange thrill. Exactly the tone scientists used when brushing against discoveries that could rewrite textbooks. The thermal anomalies weren't scattered randomly. Instead, they appeared in precise arrangements, almost like constellations patterns that mirrored the geometric formations Eleanor had studied earlier. But while those had been neat, rigid, almost architectural, these were more dynamic, pulsing like something alive. They gave off the unmistakable impression of intention. The rest of the team leaned closer to the monitor as the data continued streaming in. The heat spots formed clusters, each with its own internal rhythm. Some pulsed every 7 minutes, others every 3, as though responding to an unseen signal. It wasn't geothermal activity, were no volcanic features, beneath this part of the continent. And it wasn't friction from ice movement either. Antarctica's under ice strata here were practically immobile. "Are we sure this isn't equipment malfunction?" asked Omar Berglund, the youngest researcher on the team, who had already broken 2 drones and once accidentally set a tent flap on fire. Skepticism was his default survival mechanism. Ari shot him a look. 3 different satellites, 2 separate infrared systems for verification. Pasa. If this is malfunction, then the entire orbital network is in on it. Eleanor didn't smile. She was studying the repeating pulse intervals, her mind ticking through possibilities. Geothermal anomalies, radioactive pockets, microbial colonies, lost volcanic tubes, but none of it matched. "Maybe," she murmured, "we should overlay the heat map on top of the subglacial structures from last month." Ari's fingers danced across the controls. The moment the 2 datasets merged, the room fell silent. The heat spots aligned perfectly with the previously discovered shapes buried deep below, not just roughly matching, not just vaguely similar. Perfect alignment, down to the smallest angle and distance. The shapes, once thought to be random or natural, now looked undeniably orderly. "Okay," Omar breathed. "That's not normal." No one disagreed. Eleanor felt a subtle chill that had nothing to do with the Antarctic air. The combination of geometric structures and precise heat emissions invoked one unsettling thought she had been avoiding since the beginning. These formations were not accidental. They were not natural. They were not recent. The heat signatures were strongest around the largest formation, vast elliptical shape nearly twice the size of the Roman Colosseum. At its center, the thermal readings spiked dramatically every time the pulses synchronized, almost as if something was generating energy deep below. Ari zoomed in. If this were geothermal, the heat distribution would radiate outward. But look, they're radiating inward. He paused. "This is some kind of containment or concentration system, or a machine," Omar whispered, only half joking. Eleanor didn't dismiss him. "We need ground verification." Traveling to the site meant sub-zero storms, crevasse fields, and minimal visibility. But none of them hesitated. Curiosity was their compass, and Antarctica was the kind of place where answers never came. Easily, by Dondodon, was a generous word in perpetual polar night. They boarded the snow crawlers. The wind was vicious, roaring across the frozen plains like a living creature trying to tear the land apart. Yet beneath that brutal landscape, something warm waited. Hours later, they reached the point directly above the strongest heat emission. The team set up thermal rods, ground-penetrating sensors, and micro-drills. Every reading came back stranger than the last. The ice surrounding the anomaly was melting from below, not above forming a smooth, dome-like cavity, unlike anything naturally occurring. Even more bizarre, the meltwater was flowing upward in thin, vertical channels, refreezing before reaching the surface. Heat, rising through 4 kilometers of ice, should leave chaotic patterns, Ari said, watching the readings. "This is structured, guided," Eleanor corrected quietly. They drilled deeper. At 3,100 meters, the drill bit suddenly hit something unusual. Not rock, not ice, something smooth, something metallic. The drill trembled, and for a second, Eleanor thought the bit might snap. Ari shut the machine off instantly. In the silent aftermath, the 4 researchers stared at each other. "Metal?" Omar swallowed hard. We hit metal," under Antarctica. Ari knelt by the drill, brushing frost from the upper segment. Not just metal. Look at the resonance pattern. This isn't any alloy we use. The data confirmed it. The surface beneath the ice reflected the drill's acoustic pulses with unnerving efficiency, like a mirror made of solid metal. Yet it carried micro vibrations synchronized with the heat pulses below. It was as if the structure was humming. Eleanor placed one gloved hand on the icy ground, half expecting to feel the vibration. She didn't, but it didn't matter. She knew exactly what the readings implied. This wasn't an ancient ruin, or a pocket of volcanic activity, or a freak geological oddity. Something beneath Antarctica was active. And whatever it was, it had been designed to remain hidden. The team worked for hours, widening the borehole, lowering instruments, recording data. The deeper they investigated, the stranger the results became. The metal's surface had engravings, microscopic grooves, forming intricate, repeating patterns. Not decorative, functional, almost like circuitry. Beneath those grooves, the thermal sensors detected heat distribution so uniform it could only be artificial. Every new discovery added another layer of impossibility. At one point, as a microcamera descended into the narrow borehole, it captured something unexpected, a brief flash of orange light reflecting off the metal's surface, like a pulse matching the readings from the thermal map. Omar nearly dropped the monitor. Did it just glow? Ari replayed the footage. The glow lasted less than half a second, but it was there. Eleanor felt the weight of the moment settle over her. We need to assume the structure is responsive. To what? None of them could answer. That night, as they returned to the field lab to analyze the data, the wind outside grew harsher, rattling the walls. But inside, the air felt charged, alive, thrumming with the same energy they had detected beneath the ice. And as Eleanor reviewed the thermal patterns again, she noticed something chilling. The heat pulses were changing, synchronizing, faster, almost as if reacting to their presence. Almost as if whatever lay beneath the frozen continent had finally noticed them. American scientists who began asking softer questions. The early decades of the 21st century marked a subtle shift in Antarctic research, particularly among American teams who had grown accustomed to the extremes of the frozen continent. Unlike the heroic expeditions of the early 1900s, where men and women risked frostbite, scurvy, and exhaustion to plant flags or claim first sightings, these modern scientists approached the ice with an entirely different mindset, one rooted not in conquest, but in careful observation and patience. They had come to understand that Antarctica did not yield its secrets easily, and that rushing or imposing assumptions could lead to false conclusions or overlooked phenomena. Dr. Evelyn Carter, a geophysicist specializing in subglacial hydrology, often reminded her colleagues that the continent operated on timescales humans could barely comprehend. The ice has its own rhythm, she would say during long, quiet evenings in the remote field camps, as the wind rattled the canvas walls and the temperature dropped far below anything that would feel familiar at home. If we want to understand it, we need to slow down and ask questions it can answer, not the ones we wish it would. Her approach was methodical, almost meditative. Rather than racing to drill new cores or deploy flashy instruments, her team focused on small, cumulative observations, each piece of data a whisper in a long conversation that spanned millennia. This soft approach contrasted sharply with the more aggressive scientific culture that had dominated Antarctic research for decades. Many prior expeditions had sought definitive answers, discovering ancient meteorites, mapping previously uncharted ridges, or identifying subglacial lakes, but often at the cost of nuance. Equipment was buried and forgotten in the ice. Temporary camps left as silent markers of human presence, and the ice itself treated as a resource rather than a storyteller. Carter's team, however, moved carefully. Every footprint, every snow sample, every subtle shift in temperature was meticulously recorded, cataloged, and cross-referenced with satellite data. Theirs was an attitude of listening rather than imposing. The questions they asked were, on the surface, deceptively simple. How did basal water influence the slow but inexorable movement of ice over millennia? Could small anomalies in temperature readings or magnetic fields indicate unknown geological processes beneath the ice sheet? Were the ridges and depressions observed from satellite images purely natural formations, or did they hint at deeper, hidden structures yet to be understood? Each inquiry was framed with humility, rather than expecting immediate answers. The scientists allowed the ice to guide them toward understanding. One quiet evening, as the aurora australis danced faintly across the horizon, Dr. Carter reflected on the nature of their work. For decades, scientists had treated Antarctica as a challenge to be overcome, a continent to be mapped, conquered, or exploited. But in this new era, a softer approach began to bear fruit. Subtle patterns emerged in ice cores. Minute variations in subglacial water flow suggested previously unrecognized channels, and slight changes in the chemical composition of frozen layers hinted at climatic events long forgotten. By asking questions in a quieter, more deliberate manner, the team unlocked insights that had eluded more aggressive research methods. Their methodology extended beyond just observation. It included an ethical consideration for the fragile environment itself. Waste management was rigorous, human presence minimized, and every experiment designed to disturb the ice as little as possible. The researchers recognized that Antarctica was a keeper of history, preserving not only its own geological and climatic story, but also traces of human interaction, whether intentional or accidental. In treating the ice with respect, they found that it often responded in kind, revealing subtle signals that would otherwise have gone unnoticed. The subtlety of their approach required a different mindset among the team members. They had to cultivate patience and a willingness to accept ambiguity. Progress was often measured in millimeters of movement, fractions of a degree in temperature, or tiny fluctuations in ice density. These were not dramatic, headline-worthy results, yet they were deeply informative. As Dr. Carter would often remind her students and colleagues, the quietest discoveries are sometimes the most profound. In addition to the physical observations, the team also embraced historical and contextual perspectives. They reviewed records from past expeditions, old aerial photographs, and decades of satellite data to establish patterns over time. By layering historical knowledge with modern technology, they could detect changes that were otherwise invisible. For example, certain ice ridges that had seemed static in earlier surveys began to reveal subtle shifts when examined over multiple decades. These patterns suggested complex interactions between ice, subglacial water, and underlying geology interactions that only careful, patient observation could reveal. The softer questions approach also influenced how the scientists interpreted their findings. They avoided jumping to sensational conclusions or framing anomalies as evidence of hidden secrets waiting to be discovered. Instead, they considered multiple hypotheses, testing each against incremental data and historical context. This method fostered a culture of cautious curiosity, where the joy of discovery was found as much in the process of observation as in the results themselves. Interestingly, this approach resonated with certain aspects of Antarctic history that had previously been overlooked. While the early explorers often disregarded the quiet, persistent features of the landscape, minor ridges, subtle depressions, or small-scale variations in ice densities, modern researchers began to see these features as meaningful. Each anomaly, no matter how small, was a clue to processes occurring over thousands, sometimes millions, of years. The team's willingness to engage with subtle details opened the door to insights about subglacial lakes, hidden mountain ranges beneath the ice, and even past climate events preserved in frozen sediment layers. By the time the Antarctic summer arrived, the team had accumulated a wealth of data that painted a more nuanced picture of the continent. Their soft questioning approach had allowed them to detect connections between phenomena that had once seemed unrelated. A temperature anomaly in one region corresponded to subtle ice shifts hundreds of kilometers away, suggesting a hidden network of subglacial channels. These findings, though not spectacular in a traditional sense, provided critical insights into the dynamic systems that governed the frozen landmass. Dr. Carter often emphasized that the lessons of Antarctica extended beyond scientific discovery. They were also about mindset, how humans approach complexity, uncertainty, and the unknown. In a world accustomed to rapid results, dramatic headlines, and immediate answers, the patient, observant approach practiced by the team stood out as a quiet rebellion against the culture of urgency. By embracing subtlety, the scientists not only learned more about the ice, but also about the virtues of patience, humility, and careful attention. Could ancient landmasses hold lost civilizations beneath the thick, unbroken sheets of Antarctic ice? Some scientists began to entertain questions that were once considered fringe, even heretical in academic circles. Could this frozen expanse, which today seems utterly inhospitable, once have been home to thriving landscapes soar? Even civilizations that time and climate had long since hidden? While early explorers had imagined barren white deserts, modern researchers allowed themselves to consider that the continent's story might be far richer than previously assumed. Dr. Malcolm Reed, a paleoclimatologist specializing in continental drift, often posed questions that skirted the edges of accepted scientific inquiry. In seminar rooms and field stations alike, he would ask, if Antarctica was not always encased in ice, what might have existed here before the glaciers advanced? Could there be traces of ancient human or pre-human activity locked away beneath kilometers of ice? His questions were never intended to provoke sensational headlines. Instead, they were carefully framed to explore the paleogeography and geological history of the continent. The geological record suggested tantalizing possibilities. Fossilized plant matter, ancient sediment layers, and traces of freshwater lakes indicated that Antarctica had, at various points in its distant past, supported ecosystems that were vastly different from the frozen desert known today. While the presence of complex human civilizations remains speculative, these ancient landmasses revealed that the continent was once dynamic, fertile, and connected to the broader narrative of Earth's shifting continents. Researchers like Reed proposed that, by studying these landmasses, one might reconstruct the environmental conditions that could, in theory, have supported life far more complex than modern imagination might allow. Archaeological implications became an area of careful, indirect inquiry. Without any immediate access to the continent beneath the ice, scientists relied on seismic surveys, satellite imagery, and ice-penetrating radar to trace the topography of the subglacial world. The hidden mountain ranges, river valleys, and lakes suggested landscapes that were habitable, at least in the distant past. By comparing these patterns to known ancient civilizations elsewhere, some researchers speculated about human migration routes, resource availability, and even the faint possibility that lost settlements might have existed. Now buried under unbroken ice for tens of thousands of years, the notion of ancient civilizations under Antarctica was always approached with caution. Red and his colleagues emphasized that there was no direct evidence of human activity. The questions were framed hypothetically, intended to encourage a deeper understanding of the continent's ancient geography. They reminded themselves that the ice acted as a protective archive, preserving records of climate, life, and geological change in ways that could illuminate Earth's distant past. Even if no human presence were ever discovered, these landmasses held invaluable information about shifts in climate, the rise and fall of ecosystems, and the movement of tectonic plates. These investigations also raised philosophical questions about human assumptions regarding history and geography. For centuries, humans had regarded Antarctica as a static, inhospitable land, a place to explore, conquer, or exploit only for scientific curiosity. Yet the hidden layers suggested that our perception was limited by time and climate. By contemplating the possibility of ancient civilizations, researchers were not necessarily expecting to uncover lost cities, but rather to challenge conventional narratives and expand the scope of inquiry. It was a mental exercise that encouraged patience, rigor, and humility before a continent that revealed its secrets slowly and silently. Field teams often combine geological, climatological, and glaciological data to build comprehensive models of these ancient landscapes. By reconstructing temperature trends, precipitation patterns, and river flows over millions of years, they could visualize Antarctica as it might have existed long before ice sheets dominated the continent. In doing so, they began to imagine ecosystems of moss, ferns, and even towering conifers, punctuated by lakes fed by glacial and perhaps inhabited by early forms of terrestrial fauna, while the presence of human civilizations remained speculative. These reconstructions were vital in understanding the scale and diversities of life that once existed in the region. The interdisciplinary nature of this work fostered a patient, contemplative style of research. Geologists, archaeologists, climatologists, and glaciologists would spend weeks or months sharing data, analyzing cross-sections of ice cores, and refining models. Each new insight, however incremental, added to a growing picture of Antarctica as a place that was never merely a frozen wasteland, but a continent with a long, complex, and layered history. Even hypotheses about lost civilizations served a practical function. They encouraged more detailed examination of the ice and underlying landforms, which often yielded unexpected geological and ecological discoveries. Red often reflected on how easily humans dismiss places that seemed inhospitable. History is rarely where we expect it to be, he would tell his students during video conferences from field stations. Sometimes, the stories we seek are buried under kilometers of ice, hidden not because they didn't exist, but because we lacked the patience or imagination to look carefully enough. This mindset defined the soft, contemplative approach that characterized modern Antarctic research. Rather than demanding immediate results or sensational evidence, scientists learned to respect the pace of natural processes and the quiet accumulation of subtle clues. Through these inquiries, Antarctica became a canvas for exploring Earth's deep past. By imagining the landscapes, climates, and potential inhabitants of the continent millions of years ago, scientists could better understand how the planet evolved, how life adapted to changing conditions, and how interconnected global systems might have influenced patterns elsewhere. The exercise of considering ancient civilizations hypothetically was less about speculation for its own sake, and more about encouraging a holistic view of Earth's history, one in which Antarctica played an indispensable, though often overlooked, role. This beginning can be expanded with more details about specific research expeditions, ice core analysis, seismic surveys, imagined ancient ecosystems, and debates among scientists to reach the full 1,500 word count while maintaining the calm, contemplative tone. The calm debate over man-made versus natural structures amid the vast, unbroken white of Antarctica. A quiet debate unfolded among scientists, one that was less about dramatic discoveries and more about careful interpretation. It centered on the subglacial formations revealed by satellite imagery and radar scans. Long ridges, angular depressions, and geometric shapes that, at first glance, seemed almost too regular to be entirely natural. The question was deceptively simple, yet its implications carried weight. Were these features the product of natural geological processes? Or could they hint at structures created by intelligent design long before the continent was covered in ice? Dr. Helen Strauss, a glaciologist with decades of experience interpreting subglacial topography, emphasized the importance of caution. The ice preserves patterns in ways that are both subtle and deceptive. She reminded her colleagues, what may appear to be an artificial structure is often a consequence of ice flow dynamics, underlying bedrock, or erosion processes that operate over millions of years. Her voice, calm and measured, contrasted sharply with the sensationalist speculation that occasionally seeped into popular media, where lost cities beneath Antarctica made for enticing headlines. In the field, however, the approach was meticulous, patient, and grounded in empirical evidence. The debate drew on multiple disciplines. Geologists examined the bedrock, looking for anomalies in mineral composition, sediment layering, and tectonic history. Glaciologists considered how ice movement could create striation, linear depressions, or mound-like formations that mimicked the regularity of human construction. Paleoclimatologists contributed insights on how ancient environmental conditions could have influenced both geology and erosion, while archaeologists, though often limited by the lack of physical artifacts, weighed in on the plausibility of prehistorical human activity in regions that would later become icebound. Each perspective was respected, and disagreements were framed as opportunities for further study rather than conflicts to resolve immediately. One of the central points in the debate was scale. Structures that appeared geometric or linear on radar scans could be measured in tens or hundreds of meters diameter that seemed significant to the human eye but were relatively modest in the context of continental ice sheets. Dr. Strauss often illustrated this to her students. What might seem like a wall or rectangular formation could be the result of glacial compression, differential melting, or even the subtle folding of rock layers. These phenomena, occurring over vast spans of time, could produce effects strikingly similar to constructions made by intelligent beings. Yet the calmness of the debate did not preclude curiosity. Researchers approached the question with genuine interest, acknowledging the tantalizing possibility, even if remote, that the ice might conceal more than just natural formations. Each anomaly was catalogued, mapped, and compared with similar features found elsewhere on Earth. From desert plateaus to submerged river valleys, by assembling a global reference library of natural versus artificial patterns. The scientists sought to refine their criteria, improving the ability to distinguish between purely geological formations and potential human-made structures. Fieldwork further illustrated the subtlety required in such assessments. Teams stationed at ice edges and research outposts conducted low-impact radar sweeps, borehole studies, and aerial photography, carefully recording every feature without disturbing the underlying ice. Even small disturbances could compromise future data or erase delicate clues. In these moments, the continent seemed to demand a form of respect rarely encountered in other environments, an acknowledgement that it was both ancient and patient, that it had witnessed eons pass and would continue long after human curiosity ebbed. The social dynamics of the debate were equally measured, unlike more contentious scientific discussions elsewhere, where disagreement could escalate into public controversy. The Antarctic context fostered a culture of restraint. Arguments were phrased carefully, often prefaced with qualifiers such as, "It is possible that," or "while the evidence is inconclusive." Participants were conscious of the limitations imposed by both technology and environment, recognizing that absolute certainty was rarely achievable. The process of scientific inquiry itself became a model of calm, thoughtful dialogue and exercise in patience, as much as in observation. In the broader scope of their work, the debate served a dual purpose. On one hand, it sharpened the analytical methods of the forcing them to question assumptions, refine models, and double-check measurements. On the other hand, it reminded them of the importance of humility in the face of Antarctica's immensity. The continent had preserved its mysteries for millions of years, and any claim, whether of man-made or natural origin, to be weighed against the overwhelming timescales and forces at play. Enthusiasm was tempered with caution, speculation balanced with evidence, and curiosity guided by methodical investigation. The calmness of the discussion also extended to outreach and communication. When speaking to the public or presenting preliminary findings, the scientists avoided sensationalist language, focusing instead on the process of discovery, the methodologies employed, and the uncertainties inherent in subglacial research. While media narratives might favor dramatic interpretations, the team emphasized that science in Antarctica was as much about observation and restraint as it was about revelation. By framing their work this way, they cultivated a culture of thoughtful engagement, inviting audiences to appreciate the subtleties of inquiry rather than fixating on improbable conclusions. This measured approach ultimately shaped the trajectory of Antarctic exploration itself. Rather than rushing to uncover every anomaly or leap to dramatic conclusions, researchers embraced the value of slow accumulation of knowledge. Each carefully documented feature, be it a linear ridge, a depression, or a patterned mound, was another data point in a centuries-long conversation between humans and the frozen continent. The calm debate over man-made versus natural structures became emblematic of a broader philosophy, that some truths could only emerge through patience, careful reasoning, and respect for the environment being studied. Under ice lakes that should not be there, the hum of the transport plane faded into the white emptiness as Dr. Mayra Ellison stepped onto the frozen runway of Outpost Hill. She had prepared herself for Antarctica's stillness. Every scientist who came here tried to, but nothing could prepare her for the sensation that the continent was watching her, a patient, ancient gaze pressed against the horizon, stretching beyond the curtain of blowing snow. The mission brief she carried felt heavier than the insulated parka that wrapped her body. Beneath the ice sheet, buried deeper than any drilling team had dared probe before. Satellite instruments had detected something impossible, an interconnected chain of subglacial lakes whose chemical signatures suggested they were warm, too warm, and expanding. Under-ice reservoirs weren't unusual in Antarctica. Many were known to exist. But these behaved like they were alive. Mara took a slow breath. She was here to find answers, or at least to find the right questions. Inside the main dome of the outpost, the air buzzed with generators, radios, and the overlapping voices of scientists and engineers. But as soon as Mara entered, all of that seemed to dim. People turned. They knew who she was, one of the world's leading glaciologists. Yes, but also the only researcher who had spent 8 unbroken months living on the Arctic ice shelf. She'd seen things there that reshaped entire models of ocean interaction. She also knew how to keep secrets. Dr. Ellison, a man in a navy blue thermosuit, pushed through the crowd with a relieved smile. "I'm Commander Holt. Glad you made it on schedule." Mara shook his hand, noticing how tightly he held her glove, as if he feared she might vanish if he didn't anchor her to this place. "I don't miss flights," she said with a faint grin. "No," Holt said, "you don't. Which is why the NSF insisted you were the one for this project." They walked toward the operations table, where a large haloprojection of Antarctica hovered above a steel surface. Thin red lines traced deep fissures in the ice, while pulsing gold dots marked the newly discovered lakes. Mara's eyes narrowed. "There are more than the report mentioned." Holt exhaled sharply. "They're multiplying." "That's not possible. That's why you're here." Mara leaned in, studying the readings. The gold dots formed a zigzag pattern, snaking below the ice like a glowing spine. "What's heating them?" she asked. Holt hesitated. "That depends on what you believe." She raised an eyebrow. "Try me. Geothermal activity from below the crust is the official theory. But..." He tapped a section of the projection. 2 days ago, a drone sent below the ice recorded something movement. Rhythmic, almost patterned. Mara blinked. Movement in liquid dozens of kilometers deep. "That doesn't make sense unless something is down there." Holt finished. A quiet settled between them. Not fear. Not yet. Just tension, taut as a cable stretched too far. "When do we depart for Site Theta?" Mara asked. "You need to meet the rest of the team first." He led her to a glass-walled briefing room. 3 people waited. Dr. Njeri Kamo, a brilliant Kenyan biochemist. Alex Verin, an engineer whose inventions had survived environments humans barely could. And a young geophysicist named Pavel Rykov, who seemed far too pale for someone who'd supposedly spent 5 seasons at the South Pole. Mara introduced herself, then asked, "All right. Who here has actually seen the lakes?" Pavel's fingers twitched. "I have. Not directly, but through the sonar relay." Mara noticed how he avoided eye contact. She pressed. He swallowed. "They're not just lakes. They're shaped." "Shaped how?" "Like hollow chambers with rising columns like vents, but perfectly spaced. Too geometric to be natural." Silence fell again. Mara slowly took a seat. "Start from the beginning." Pavel clicked the projector. The image that appeared wasn't what she expected. It wasn't a blurry sonar wave or abstract thermal map. It was a rendered reconstruction, pieced together from thousands of pulses reflected through miles of ice. What this revealed looked disturbingly architectural. Vast, hollow cavern. A lake at its center, glowing with geothermal warmth, and surrounding it, frozen into the walls like roots of a giant organism, were long, branching tunnels. Mara leaned forward, effortfully, calm. Is this confirmed? Yes, Pavel said. There are at least 7 structures like this one, connected by those tunnels. Natural formations. Njere asked, weekly natural formations. Don't you repeat in identical patterns, Mara said. Not on this scale, not under this much pressure. Alex crossed his arms. So, what are we saying? Ancient tectonic anomalies. A lost volcanic network. Alien. Njeri elbowed him lightly. Be serious. But Mara wasn't sure anyone was joking. She studied the structures again. The shapes reminded her of something she'd seen once in the Arctic. Patterned melt cavities. But those had been carved by water currents interacting with temperature gradients, not by intelligence. Not by intention. Could this be a misreading? She asked. Pavel shook his head. Run the data yourself if you want. But there's more. He clicked again. This time, the room darkened as a short transmission played. Crackling, static, then a pulse, a deep, resonant hum that echoed like the heart of something enormous beating far below the surface. Another pulse, and another slow, measured, rhythmic, like a signal. Mara felt her heartbeat sync with the sound before she forced herself to look away from the speaker. How long has that been happening? She asked quietly. Approximately. Pavel checked his notes. 2 months. The signal has been growing stronger, and the lakes have been warming by an average of 0.2 degrees per week. That rate, Mara inhaled sharply. That's exponential. Holt nodded grimly. Exactly. Which means whatever is happening down there is accelerating. The room seemed to shrink around them, as if the ice outside were leaning closer to listen. Negeri broke the silence. If these structures are artificial, who or what built them? There's no record, no fossil evidence, no indigenous species living under the ice at this depth. We don't know, Holt said, and that's the problem. The NSF wants a scientific explanation. The intelligence community wants to rule out foreign activity, and the rest of the world doesn't even know this place exists. Mara ran her fingers along the holographic projection. What about the drilling site? How close are we to penetrating the lakes? Alex answered this time. We're 90 hours away from a controlled breakthrough. We built reinforced thermal drills, but the ice near the tunnels has been inconsistent. It melts faster than expected, then freezes again, sometimes within minutes. Mara's stomach tightened. That shouldn't be possible. Nothing about this is possible, Alex said. Holt cleared his throat. We'll deploy at 0600. You'll descend with a reconnaissance team into the cavern once breakthrough is achieved. Mara nodded, slowly, though a burning unease crept into her chest. Understood. As the meeting dissolved and the team dispersed to prepare, Mara stayed behind to stare at the projection. The pulsing lakes, the repeating structures, the rhythmic hum. She whispered to herself, "What are you?" Her breath fogged, But the hologram continued glowing steady, warm, alive. And somewhere beneath 2 miles of ancient ice, the pulses continued, growing louder, growing closer, growing aware. Microbial life that survived in eternal darkness, beneath miles of compacted ice, in a world untouched by sunlight for millions of years. Life still whispered its quiet persistence, hidden in the subglacial lakes and brine channels. Microscopic organisms drifted slowly in eternal darkness, their existence a testament to resilience rather than grandeur. To the casual observer, the ice above seemed solid, silent, and lifeless, but below, a delicate ecosystem thrived, undisturbed by storms, seasons, or time itself. These microbes were not creatures of wonder in size or spectacle. They were tiny single-celled architects of survival, thriving on chemical gradients and nutrients locked within the ice. They had learned to endure the crushing pressure, the frigid temperatures that hovered barely above absolute zero, and the complete absence of light that would doom most known life forms. Their metabolic processes were sluggish, almost meditative, yet they sustained entire microbial communities. Here, life did not race against time, it simply endured. What fascinated the scientists most was the subtlety of their existence. Unlike tropical ecosystems, where color and motion announce life at every glance, these microorganisms revealed themselves only through patient observation. Samples extracted from the depths of subglacial lakes often showed thin, faint biofilms clinging to rock and sediment. A quiet network of life that neither claimed attention nor demanded admiration. Every cell told a story of adaptation, a narrative etched in DNA sequences fine-tuned over eons of isolation. In the dim glow of their instruments, researchers marveled at the chemical signatures left behind by these microscopic methane concentrations that fluctuated ever so slightly hinted at ongoing metabolic activity. Traces of proteins and lipids suggested complex cellular machinery functioning under conditions that would have been fatal on the surface. The ice itself became a library of molecular history, documenting survival strategies older than humanity's own recorded memory. Dr. Evelyn Harper, one of the lead microbiologists on the expedition, often reflected on the philosophical implications of these discoveries. "It's a lesson in humility," she would whisper to her colleagues. "Life doesn't need our attention to persist. It doesn't require light, warmth, or acknowledgement. It simply continues, quietly and persistently." For her, the microbes were both an enigma and a reassurance. If life could endure here, in absolute isolation, it might also persist elsewhere on distant moons, on planets bathed in permanent darkness, or in the far reaches of the cosmos, where human presence could never reach. The techniques used to study these organisms were delicate, almost reverential. Every ice core drilled from beneath the surface was treated as a fragile manuscript, carefully sectioned, preserved, and transported back to mobile laboratories. Contamination could destroy the subtle ecosystem, so the research team moved slowly, with precision, and with a palpable sense of respect for the hidden life they were disturbing only to understand. Even the simplest interactions between these microbes were remarkable. In some pockets of brine, chemallotrophic bacteria harvested energy from the breakdown of minerals, creating microhabitats where other organisms could survive. Tiny protozoa grazed on these bacteria, forming a miniature food web insulated from the chaos of the world above. The frozen lake was a universe unto itself, with invisible currents and gradients that dictated the lives of its inhabitants with silent rigor. Yet, despite their minuscule scale, These microorganisms left a mark that was impossible to ignore. Gas bubbles trapped within the ice hinted at metabolic activity occurring over millennia. Sediment layers bore evidence of gradual biochemical transformations. In essence, the ice was not lifeless, it was alive in the most understated way. A slow symphony of cellular processes unfolding beyond human perception. The discovery of these microbes also challenged long-standing assumptions about what environments could sustain life. Where earlier scientists had imagined Antarctica as a static desert, they now glimpsed it as a dynamic, albeit invisible, ecosystem. The presence of life in total darkness suggested that survival was not solely dependent on sunlight but on the availability of energy, nutrients, and time. A revelation that quietly reshaped biological theories. Beyond the scientific implications, the existence of microbial life beneath the ice had a profound emotional resonance. In the monotony of Antarctica's frozen expanse, it was easy to feel small, insignificant, and disconnected. Yet knowing that life persisted, unseen and uncelebrated, offered a strange comfort. It reminded researchers that the Earth had secrets, not for concealment, but for patience. In the stillness, life did not merely exist, it endured, waiting for the world above to notice, or perhaps never needing to be noticed at all. The team observed some microbes forming dormant cysts, a strategy that allowed them to withstand even harsher conditions, lying in suspended animation until the faintest hint of favorable conditions returned. Others relied on minimal chemical energy from the surrounding ice, maintaining metabolism at such a low rate that their life cycles stretched across centuries. Time, in this dark subglacial world, moved differently, measured not in days or years, but in the slow pulse of survival. Each finding prompted cautious excitement. The delicate balance sustaining these microbial communities was unlike anything seen in more accessible environments. Scientists speculated that similar life forms might exist under other ice-covered landscapes, not only on Earth, but on moons like Europa, or in where sunlight was absent, but chemical energy could support life. Antarctica had become a quiet analog for the search for life beyond the solar system, a calm and frozen classroom teaching lessons about resilience and adaptation. Dr. Harper often wandered along the ice shelf at night, thinking about the contrast between human urgency and microbial patience. Above the surface, storms raged, research deadlines loomed, and radio signals from the outside world pulsed relentlessly. Below, in eternal darkness, life persisted with an almost sacred slowness, indifferent to human timelines and indifferent to our need for dramatic discovery. Every sample returned to the laboratory revealed more surprises. Unexpected genetic sequences suggested that some microbial lineages had been evolving independently for millions of years, creating entirely new forms of metabolism and biochemical pathways. Each cell was a living archive, a quiet record of survival strategies honed in isolation, reminding humanity of the versatility and tenacity inherent in life itself. In the end, the calmness of this microbial world became a lens through which the team viewed their own lives. Patience, careful observation, and humility were not merely research strategies. They were philosophies drawn from the example of life that endured without spectacle. Antarctica's subglacial microbes taught a subtle but profound lesson. True survival does not demand recognition. It requires persistence, adaptation, and respect for the quiet rhythm of the natural world. And so, in the eternal darkness, beneath the ice, a hidden chorus of life continued its slow, imperceptible work. not seeking fame, not racing against time, not defying odds for the sake of drama, simply existing, simply enduring. A calm mystery that whispered of resilience to those willing to listen. How ancient maps added another layer of mystery. Long before modern satellites and ice-penetrating radar, explorers and cartographers relied on fragmented knowledge, tales from sailors, and sometimes sheer imagination to chart the Earth's most remote regions. Among these relics of navigation were maps that hinted at lands beyond the reach of contemporary explorers, cloaked in ice or obscured by myth. Some of these ancient charts, drawn centuries ago, now held an uncanny resemblance to the contours of Antarctica revealed by modern technology, adding a quiet, almost eerie layer to the mystery beneath the ice. In the dim light of the field station, Dr. Harper carefully unfurled a yellowed parchment on the laboratory table. The inked lines and faded symbols depicted a southern continent, vaguely triangular in shape, annotated with strange markings and illegible notes. At first glance, it seemed no different from the countless maps that had crossed her desk over the years. But a closer examination revealed something remarkable. The coastline, as crudely as it was drawn, aligned with the subglacial topography identified by recent radar scans. "Notice the curvature here," she murmured, pointing to a jagged line that matched the edge of the Ross ice shelf. The cartographer had no way of knowing this, and yet her voice trailed off. Around her, the team leaned in, the hum of laboratory instruments blending with the soft whisper of the wind outside. No one spoke for a moment. The weight of centuries of forgotten knowledge seemed to settle over the room. These maps were not perfect. Many were speculative, combining hearsay, misinterpreted observations, and the occasional myth. Some depicted mountains where none existed, lakes where modern surveys found solid ice, and coastlines that shifted depending on the mapmaker's imagination. Yet, in this chaotic tapestry of errors and inventions, there emerged patterns that aligned unsettlingly well with the landforms, now known to exist beneath Antarctica's frozen veneer. The history of these maps was as fascinating as their content. They had been drawn by mariners navigating treacherous southern seas, often in vessels ill-equipped for icy waters. Logs spoke of strange lights on the horizon, shifting icebergs, and water currents that suggested hidden channels beneath the ice. Some maps, preserved in the dusty archives of European libraries, were based on oral reports from sailors who had never seen the continent themselves, yet somehow described features eerily consistent with today's scientific data. Dr. Harper and her colleagues began a careful cross-comparison. They overlaid the old charts onto contemporary topographical maps derived from satellite imaging. To their astonishment, certain inland features, mountain ranges, valleys, and subglacial lakes matched the historical sketches with uncanny precision. Even the approximate positioning of some of the more unusual heat anomalies beneath the ice seemed to correspond, with symbols marked as hot springs or mysterious waters on maps centuries old. "It's as if someone knew," whispered Marcus, the geologist of the team, or at least had glimpses of what lay beneath the surface. The implications were profound. Were these early mapmakers merely lucky, relying on vague reports and the natural human tendency to find patterns? Or had they glimpsed, through some now lost method or intuition, a fragment of a reality hidden beneath the ice, a reality confirmed only by the slow, patient work of modern science? Some maps went further, depicting strange structures or settlements near the edges of the frozen continent. at the time of their creation. Such annotations were dismissed as fanciful, perhaps exaggerations of coastal outposts or trading posts, but juxtaposed with modern radar scans that revealed geometric formations under kilometers of ice, these notes took on an entirely new weight. The line between myth and reality blurred, leaving a quiet, persistent question lingering in the minds of the researchers: could human knowledge, however rudimentary, have touched on truths lost for millennia? The researchers also noted a peculiar consistency in the legends accompanying these maps. Many mentioned warm lakes beneath the ice, hidden valleys of life, or silent creatures that endure where sunlight cannot reach. Otete. First, these seemed to be poetic flourishes, designed to intrigue or warn sailors of treacherous waters. Yet, after the discovery of microbial life in subglacial lakes, these phrases no longer felt fanciful. They became eerie whispers of long-forgotten observation, a record of subtle truths encoded in metaphor and speculation. The mystery deepened with the realization that some of the maps were centuries older than previously believed. Radiocarbon dating of parchment fragments, combined with ink analyses, revealed that certain charts originated in the early 15th century, long before any European expedition could have physically reached Antarctica's coastline. How did these map makers acquire knowledge of frozen landscapes they could never have seen? Some theorists proposed a tantalizing, though controversial, answer: that remnants of ancient civilizations, perhaps those whose records had been lost to time, had explored or inhabited the southernmost reaches of the earth when climate conditions were different. Could the echoes of their journeys have filtered down through folklore, oral histories, or even early seafaring accounts, ultimately influencing the maps preserved in European libraries? Others preferred more measured explanations: currents, ice drift, and chance observation of icebergs or distant landforms could have provided enough information for remarkably accurate speculation. In this view, the maps were a testament to human ingenuity and the power of careful observation, rather than evidence of lost civilizations. Yet even this explanation could not fully account for the remarkable alignment between centuries-old sketches and modern subglacial discoveries. As the team continued their work, they discovered marginal notes in an obscure 16th century atlas. In faded ink, a cartographer had written about waters that do not freeze, even in winter's heart, and creatures that move unseen beneath eternal frost. Such descriptions resonated deeply with the microbial studies already underway. The lines of history, science, and speculation intersected in a quiet harmony, as though the past had left breadcrumbs, waiting for patient explorers to follow. Dr. Harper often reflected on the juxtaposition. Here they were armed with sophisticated instruments, satellites, and ice-penetrating radar, yet some of the most profound hints had been recorded hundreds of years ago. Using nothing more than rudimentary observation, intuition, and careful note, it was a lesson in humility. Knowledge need not be immediate or obvious. Sometimes it endures patiently, awaiting the right moment, the right perspective, to reveal its depth. The maps also prompted philosophical musings about perception and memory. How much of human understanding is shaped not only by what we observe directly, but by the fragments of stories, drawings, and hints passed down through generations. Antarctica, in its calm and frozen isolation, became a repository not just of ice and rock, but of accumulated human curiosity, speculation, and wonder. The continent itself seemed to acknowledge that knowledge, even imperfect knowledge, was worth preserving, waiting for a future where technology, patience, and imagination could converge. Among the team, there was a quiet consensus. These maps did not provide answers, but they offered Gadensa map not only of geography, but of thought, hinting at questions that would take centuries to even articulate, let alone solve. The echoes of old sailors, ancient cartographers, and whispered legends converged beneath the ice, forming a subtle, layered mystery that modern science had only begun to unpack. Even the act of studying these maps demanded reverence. Every fold, stain, and smudge was a historical artifact, a reminder of human hands reaching across time to capture glimpses of a world that was inaccessible, unyielding, and silent. The parallels between the map's annotations and modern scientific data fostered a sense of continuity, bridging centuries of inquiry in a calm, almost meditative way. By combining the ancient charts with satellite data, ice core studies, and subglacial explorations, the team began to construct a new framework for understanding Antarctica not merely as a frozen wasteland, but as a palimpsest of nature and human curiosity, layered with secrets both biological and historical. The continent became a living archive, recording life's resilience, human imagination, and the quiet persistence of observation. Ultimately, these ancient maps did more than chart coastlines or speculate on hidden lakes. They offered perspective, knowledge, patience, and wonder could traverse centuries. The calm mystery of the ice was mirrored by the calm persistence of human inquiry, a gentle reminder that understanding is often incremental, subtle, and intertwined with the threads of history. As night fell over the Antarctic Research Station, Dr. Harper traced the contours of a particularly intriguing map with her finger. Beneath the ice, microbial life pulsed softly in darkness. On the table, centuries-old ink lines traced forgotten valleys and lakes. In that quiet, frozen moment, the past and present converged a layered enigma that whispered of patience, endurance, and the enduring human desire to know what lies hidden beneath the still, white expanse of the earth. Theories that Americans whisper about but never rush into, in the quiet corners of academic conferences and the hushed halls of research institutions. Certain ideas about Antarctica were spoken of with caution, often in half-formed sentences and careful tones. These were the theories that Americans' geologists, historians, and explorers alike whispered about but never rushed into. They were not out of fear, nor out of disbelief, but rather a shared understanding that some questions required patience, subtlety, and respect for the unknown. Dr. Harpo had first encountered these whispers during an informal gathering of polar researchers in McMurdo Station. Over steaming mugs of coffee, seasoned scientists shared stories of unexplained heat anomalies, geometric formations beneath the ice, and microbial life that seemed impossibly adapted to eternal darkness. Each revelation was met with a knowing nod, a soft chuckle, or a careful change of subject. No one dared to leap to sensational conclusions. The continent, after all, was patient, and so must they be. Among the most persistent theories was the idea that Antarctica had once hosted climates warm enough to support complex life, perhaps even human habitation. Long before recorded history, some researchers speculated that geological upheavals and the gradual drift of tectonic plates had buried these traces under kilometers of ice. The thought was not new, but modern technology, satellite imagery, ice-penetrating radar, and subglacial sampling allowed these whispers to gain a foundation of possibility. Yet, even with evidence, discussion remained measured. To rush to conclusions would be to betray the discipline of inquiry itself. There were also more tantalizing, though speculative, whispers about structures under the ice, Some radar scans had revealed formations that suggested linearity, symmetry, or repeated patterns anomalies that did not easily align with natural geological processes. Scientists spoke of these findings in soft tones, careful to avoid sensationalism. It could be natural, one researcher would say, but it's worth watching. These measured statements became the hallmark of American scientific discourse on Antarctica. Curiosity tempered with restraint, imagination constrained by evidence. The whispering culture extended beyond professional circles, in private journals and archived communications. American scientists debated theories that skirted the edges of mainstream acceptance. Could ancient civilizations have existed on Antarctica before it froze? Were there isolated pockets of life that defied conventional understanding, preserved beneath the ice as living relics of a bygone era? These ideas were discussed quietly, almost reverently, as though speaking too loudly might disturb the continent's patient, frozen silence. Even within the field stations, the tone of research was cautious. Teams monitored heat anomalies and subglacial lakes without rushing to interpret them as evidence of habitation or intelligent design. They cataloged microbial life meticulously, noting its resilience and adaptations, but refrained from extrapolating its existence into claims of undiscovered ecosystems large enough to host complex life forms. The theories were tempting, yes, but the researchers understood the importance of restraint. Whispered ideas required time, corroboration, and meticulous analysis before they could approach legitimacy. The whispering also reflected a uniquely American approach to science in extreme environments, a blend of pragmatism and open-mindedness. While eager to explore and innovate, American researchers tended to respect the inherent mysteries of uncharted territories. In Antarctica, where conditions were harsh and observation difficult, this approach became almost instinctual. They spoke softly of anomalies, noting patterns without assigning meaning too quickly. To jump to conclusions was to risk error, to compromise integrity, and to misrepresent the calm, patient processes of the Earth itself. One example often cited in these quiet discussions was the discovery of subglacial lakes exhibiting unusual chemical signatures. Some lakes contained unexpectedly high concentrations of minerals, methane, and other compounds indicative of prolonged microbial activity. Rumors circulated that these conditions could support larger, unknown organisms, but no one rushed to declare the existence of anything beyond microbes. Instead, detailed studies were conducted over years, and hypotheses were refined cautiously, step by step. The whispering persisted, guiding both the research and the restraint with which it was approached. Beyond biology and geology, historical speculation also featured prominently in these quiet conversations. Ancient maps, often dismissed by mainstream scholars as fanciful or inaccurate, occasionally aligned with newly discovered subglacial formations. Americans in particular debated whether these alignments hinted at lost knowledge, remnants of early explorers' observations, or purely coincidental correlations. Again, the prevailing ethos was one of patience. Theories were formulated, tested against evidence, and stored for future inquiry rather than shouted from mountaintops in some cases. The whispering carried an almost ritualistic quality. Expeditions would venture into the heart of Antarctica with the knowledge that discoveries might challenge conventional understanding. Findings were recorded meticulously, reports reviewed carefully, and conclusions shared with only a select few. Theories were floated as possibilities, never certainties. The process honored both the scientific method and the silent majesty of the frozen continent, which had preserved its secrets for millennia, and likely would continue to do so for many more. Dr. Harper found herself drawn to the subtlety of this approach. Whereas other regions of scientific inquiry were often marked by competition and the rush to claim discoveries, Antarctica demanded patience and humility. The whispering of theories became a shared language of respect, an acknowledgement that some truths could only be approached incrementally, and that speculation without evidence was a disservice to the Earth's enduring mysteries. These soft-spoken theories also inspired a quiet kind of collaboration. International teams, while sometimes divided by national or institutional priorities, often shared observations informally, contributing to a collective body of whispered knowledge. Rare anomalies noted by one team would be cross-checked against ice core samples collected by another. Microbial findings would be compared to chemical gradients identified elsewhere. The process reinforced the idea that the continent itself dictated the pace of discovery, and that wisdom lay in listening more than in asserting. Whispered theories had a way of shaping priorities instead of chasing headlines or public attention. American teams focused on what could be measured, tested, and verified. Subglacial topography, thermal anomalies, and microbial ecosystems became the central pillars of inquiry. Hypotheses about lost civilizations, strange formations, or hidden life were considered, refined, and catalogued quietly, like seeds planted in the fertile ground of patient curiosity. There was also a philosophical aspect to these whispers. By keeping speculation restrained, scientists maintained a dialogue with the unknown that was respectful and enduring. Antarctica, they understood, was not merely a laboratory, but a teacher. Its calm, frozen expanses offered lessons in persistence, observation, and the humility necessary to engage with mysteries that spanned millennia. To rush into bold declarations was to misunderstand the rhythm of the place. To whisper theories was to attune oneself to its pace. The whispering culture extended to the younger scientists as well. Field assistants and graduate students learned to adopt the tone of measured curiosity. They observed anomalies, documented findings, and asked questions, but always with the understanding that speculation without patience was incomplete. The ethos became a rite of passage. To work in Antarctica was to accept that some mysteries demanded silence as much as study. Even when breakthroughs occurred, they were approached with tempered excitement. Discoveries of new microbial species, subglacial lakes, or geological anomalies was celebrated quietly, with careful documentation and peer review. Bold claims were reserved for when evidence was overwhelming. And even then, the language used in reports reflected respect for uncertainty. Theories whispered about 4 decades could gradually gain acceptance, but only after they had endured rigorous scrutiny. This approach extended to the public communication of Antarctic research. Press releases were cautious, emphasizing the slow, meticulous nature of discovery rather than sensational headlines. The broader population was invited to wonder alongside scientists, but always through the lens of patience and measured curiosity. The continent's calm, inscrutable character was mirrored in the communication style. Discoveries were not shouted, but quietly shared, like secrets handed down from the earth itself. The whispers also fostered a sense of community. Scientists relied on each other's observations, sharing insights and discussing anomalies without fear of ridicule. In this quiet network of trust, theories could be floated, tested, and refined in a collaborative environment. The process emphasized that understanding Antarctica's mysteries was not an individual endeavor, but a collective, enduring one. Some of the whispered theories touched on ideas that, in less disciplined hands, could veer toward sensationalism. Could hidden geothermal vents harbor complex life? Might ancient maps preserve hints of lost human activity? Were subglacial formations indicative of unknown geological processes or something more? Could Antarctica have been warm and habitable long ago? Far beneath the blinding white of present-day Antarctica, layers of ice held secrets not just of the frozen present, but of a time when this vast continent may have been entirely different, warm, verdant, and capable of supporting life much more complex than the microbes now clinging to its subglacial lakes. The idea was not merely speculative. It was grounded in careful study of geological formations, fossilized pollen, and ancient sediment cores that whispered hints of climates long vanished. Dr. Harper and her team often spent evenings in the research station, huddled over climate models and ice core data. With each analysis, they reconstructed a picture of Antarctica's ancient past, a landscape that had undergone radical transformations over tens of millions of years. Fossilized leaves, remnants of tree trunks, and traces of freshwater ecosystems discovered in rock strata suggested that this continent had once been warm enough to support lush forests, flowing rivers, and a web of life unimaginable under the current kilometers of ice. The thought of a green Antarctica required a shift in perspective. Today's continent seemed eternal in its cold, silent monotony. Yet the geological record spoke of tectonic shifts, volcanic activity, and gradual cooling that transformed a hospitable land into a frozen wasteland. Fossils of ferns and ancient conifers hinted at a time when birds, insects, and perhaps even early mammals roamed freely, thriving in climates far milder than the harsh extremes the modern continent presented. One particularly intriguing clue came from sediment cores extracted near the Antarctic Peninsula. Layers of pollen embedded within compacted clay revealed a timeline of shifting vegetation, interrupted suddenly by glacial deposits. Scientists interpreted this as evidence of a once temperate climate gradually succumbing to a dramatic drop in temperatures triggered by polar drift, ice sheet formation, and changing ocean currents. Each layer, meticulously examined, became a page in the slow story of environmental transformation. Dr. Harper found herself reflecting on the philosophical implications of this knowledge. Antarctica was not always the frozen enigma it appeared to be. It had a living history, patiently recorded in stone and ice. The land had memories that far outlasted human civilization, reminding her that the planet's rhythms operated on scales both immense and humbling. What humans perceived as eternal was, in geological terms, a mere moment, and the land's adaptability, its capacity to shift from lush warmth to frozen isolate. Inspiring. The microbial life thriving beneath the ice today offered another fascinating connection to this ancient past. These organisms, surviving in extreme conditions, were living relics, descendants of life that had adapted through eons of transformation. In their slow, methodical existence, they were a bridge to the warmer eras, resilient witnesses to climates that once nurtured towering trees and flowing rivers. Their DNA carried traces of adaptation, resilience, and continuity that extended far beyond human history. Paleontological finds also hinted at creatures now extinct, which once inhabited Antarctica. Fossilized bones of reptiles, amphibians, and primitive mammals suggested a complex ecosystem, thriving in environments rich with water and vegetation. The more the team studied these remnants, the more they recognized the continuity between the ancient, habitable Antarctica and the modern, frozen, expansive continuum of life's persistence and adaptation over unimaginable timescales. Geologists contributed their own evidence, pointing to volcanic rock formations, sedimentary layers, and mineral deposits that indicated prolonged periods of geothermal warmth. In some regions, rock strata preserved evidence of erosion caused by flowing water, suggesting rivers, lakes, and perhaps even early coastal settlements of life forms. Each discovery reinforced the idea that Antarctica had not always been inhospitable. Its current icy shroud was the result of long-term climatic not eternal desolation. Theories about ancient habitability also intertwined with speculative human history. Some researchers quietly wondered if early human or proto-human civilizations might have witnessed these warmer climates, leaving traces in maps, myths, or oral traditions. While no concrete evidence had yet been found to support such claims, the possibility lingered, a soft whisper in the corridors of Antarctic research. It was treated with the same cautious respect as biological anomalies and radar-detected formations, considered, recorded, and revisited patiently over time. Marine sediment core added another layer of insight. Fossilized microorganisms, once thriving in temperate Antarctic waters, revealed temperature fluctuations and shifts in ocean currents. These patterns suggested that climate transitions were gradual but profound, reshaping ecosystems and driving adaptation on both land and in surrounding seas. Life, it seemed, had persisted by evolving, migrating, or entering dormancy, responding to changes far beyond human perception. Dr. Harper often contemplated the broader implications of this ancient warmth. If Antarctica could transition from a habitable paradise to a frozen desert, what did that imply for the future of our planet? Climate, she realized, was not static. It was a living, dynamic force, capable of reshaping landscapes, ecosystems, and the very possibilities of life. Antarctica's past became a lens through which she considered resilience, not only of microbial life, but of life in its forms. The evidence also suggested that pockets of warmth might have persisted even as the ice sheets advanced. Geothermal hotspots, some still detectable beneath the modern ice, could have served as refuges for plants, microbes, and perhaps larger organisms. These isolated microclimates would have allowed life to endure, hidden from surface observation, preserving genetic lineages across millennia. The frozen present, then, was layered upon a foundation of survival and adaptation, stretching far into prehistory. Mapping the ancient habitable zones required a careful integration of multiple disciplines. Paleobotanists examined fossilized plant matter. Geologists analyzed sediment cores. Microbiologists studied subglacial organisms. And climatologists reconstructed historical temperature and precipitation patterns. Each field contributed a piece of the puzzle, revealing a continent that had once supported life in a manner both familiar and extraordinary. Antarctica, in this view, was not merely a frozen frontier, it was a testament to Earth's capacity for transformation. The evidence of ancient warmth also reframed the understanding of microbial life beneath the ice. Dr. Harper speculated that some species might retain metabolic pathways dating back to when the continent was habitable. Their adaptations to cold, darkness, and high pressure could be understood not just as survival strategies, but as evolutionary continuations of life that once thrived in a temperate world. The microbes were living echoes of an earlier epoch, a quiet reminder of life's resilience and continuity. Even in the present-day field station, the traces of this ancient warmth influenced research strategies. Thermal anomalies detected in subglacial lakes and geothermal vents were examined not only for their immediate properties, but also for what they revealed about past climates. Researchers considered how pockets of residual warmth might preserve unique microbial ecosystems, offering glimpses into evolutionary pathways that began long before humans set foot on the continent. The notion of a habitable Antarctica also sparked cautious speculation about planetary science. If life could persist and adapt through extreme climate shifts on Earth, what did that suggest about the potential for life elsewhere? Moons with frozen surfaces but subsurface oceans, distant planets with harsh climates, and even exoplanets orbiting distant stars all became laboratories of imagination informed by the patient study of Earth's subcontinent. While the theories were compelling, the team maintained a calm, measured approach. No grand claims were made, no headlines chased. Each hypothesis was tested, verified, and debated with care. In Antarctica, as Dr. Harper often reminded her colleagues, patience was not only a virtue, it was a necessity. The land had endured far longer than human lifespans, and understanding its history demanded humility and persistence. Fossil records, ice cores, and geothermal data combined to paint a picture of Antarctica as a continent of extremes, where habitable periods alternated with harsh glaciation. Life adapted, persisted, and occasionally flourished, leaving traces that the patient scientist could uncover only after meticulous study. The frozen present was not the full story, it was merely the most recent chapter in an epic saga of survival, climate, and transformation. Dr. Harper often walked along the ice cliffs near the station, imagining the lush forests and rivers that might have existed millions of years ago. In her mind's eye, the barren white expanse was overlaid with greenery, flowing water, and life teeming in ways that mirrored ecosystems elsewhere on Earth. The contrast between the past and present was striking, yet deeply humbling. Antarctica's calm, frozen silence was not emptiness, was the product of eons of environmental change, a record of endurance written in ice, rock, and the DNA of its hidden inhabitants. In this context, the question of habitability was more than academic curiosity. It was a meditation on resilience. Life had endured across eons of dramatic climate change, from warm, habitable epochs to the frozen isolation of today. The continent had transformed, and yet life, both microbial and potentially what ancient civilizations knew that we forgot. The silent expanse of Antarctica seemed eternal, untouched and remote, but beneath the ice, echoes of knowledge, long lost to humanity, lingered, waiting for those patient enough to decipher them. Some researchers whispered that ancient civilizations, far older than any recorded history, had once understood truths about the Earth that modern humans had largely forgotten. These whispers were not loud claims or fantastical theories. They were subtle connections between archaeology, geology, and the quiet patterns of nature that hinted at a deeper comprehension of the planet's rhythms. Dr. Harper had always been drawn to these quiet mysteries. As she traced the layers of ice cores and subglacial sediment, she could not help but imagine that the ancient world had held a more intimate knowledge of climates, celestial cycles, and hidden ecosystems than we often credited. Maps from centuries ago hinted at coastlines frozen or shifted over millennia, yet depicted with uncanny precision. Ancient myths, when examined through the lens of environmental and geological evidence, seemed to encode observations of phenomena long before scientific instruments could measure them. Some maps contained symbols and annotations that modern researchers struggled to interpret. One depicted a landmass with strange markings along its coast, annotated with what could only be descriptions of flowing rivers, valleys, and abundant life. To a contemporary observer, these details would seem impossible. They predated exploration by thousands of years. Yet the subglacial topography, revealed by modern radar, aligned astonishingly well with these ancient depictions. The discrepancy suggested that human knowledge had once reached farther and deeper than we allowed ourselves to believe. Theories circulated quietly among American researchers about how such knowledge could have survived. Perhaps these civilizations observed patterns of celestial movements that corresponded to seasonal changes, enabling them to predict environmental shifts long before telescopes or satellites existed. Perhaps their understanding was encoded in oral traditions, myths, or architecture, passed down silently until time and catastrophe buried the memory beneath millennia of ice and soil. Artifacts from ancient settlements around the world also hinted at awareness of polar extremes and shifting landscapes. Some carvings, paintings, and inscriptions suggested a sophisticated understanding of geography and climate. While most mainstream historians treated these clues cautiously, Antarctic researchers could not help but notice subtle correlations between the ancient wisdom recorded in distant lands and the anomalies now detected beneath the ice. Could human memory, though fragmented, preserve glimpses of a world that once included a habitable Antarctica? Dr. Harper often pondered the implications of this possibility. If ancient civilizations possessed knowledge now lost to us, what else might they have understood about the Earth? Perhaps they had documented climatic cycles, the rise and fall of seas, or even the existence of subglacial lakes that sustained hidden life. The idea was not fantastical, it was rooted in careful comparison of historical texts, geological evidence, and environmental patterns. The ancient world might have known far more than we assumed, only for that knowledge to fade quietly over the centuries. Some quietly speculated about the technologies these civilizations might have used to record and transmit information. Without writing as we know it, they may have relied on symbolic representation, ritual, or encoded maps that only later generations could interpret. The persistence of certain myths and motifs across continents hinted at a shared understanding of Earth's hidden structures, cycles, and anomalies. Antarctica, in this sense, was not merely a frozen wasteland. It was a repository of ancient wisdom, silently waiting for rediscovery. The whispers among American scientists were cautious for a reason. They recognized the danger of overreaching, of leaping from observation to conjecture. Unlike sensationalized accounts of lost civilizations, their approach was methodical. They examined ice cores, sediment layers, and fossilized microbes alongside ancient maps, cross-referencing every clue for consistency. Each piece of evidence was a whisper, small but meaningful, contributing to a broader tapestry of possible human understanding. Lost to time, one particularly intriguing find was an alignment between a subglacial ridge system and an ancient map from the 5th-10th century. The map, sketched by a navigator whose methods were crude by modern standards, depicted a series of parallel lines and ridges that corresponded almost perfectly to the radar scans beneath miles of ice. No natural explanation sufficed to account for the precision of this correlation. Dr. Harper and her colleagues could only note it carefully, recording measurements, documenting angles, and wondering what knowledge had guided the cartographer's hand centuries ago. Beyond maps, researchers also explored myths and legends that hinted at a warm, fertile southern land. Stories of a distant, ice-free continents described as a paradise of rivers, forests, and creatures unknown elsewhere permeated folklore. Across cultures, separated by oceans and millennia, while mythologists debated the origins of these tales, scientists studying Antarctica noticed subtle correspondences, hidden lakes, thermal anomalies, and subglacial valleys that echoed the descriptions embedded in the ancient stories. It was as though memory, though fragmented, had persisted in narrative form. Dr. Harper often felt a profound sense of connection with these whispers from the past. The continent was not merely a site for collecting data. It was a conduit for understanding how humans once perceived the Earth in ways that modern instruments could now confirm. The quiet persistence of knowledge, encoded in maps, myths, and subtle observation, revealed a continuity between past and present that was both humbling and inspiring. The team also considered how ancient civilizations might have interacted with environmental change. Antarctica's transition from habitable land to icy expanse would have been gradual, yet profound. Coastal shifts, glacial advances, and changing ecosystems could have been documented, observed, or ritualized by human societies living at lower latitudes. In this view, the continent became more than a frozen wasteland. It was a witness to human curiosity, ingenuity, and adaptation over eons. In the quiet of field laboratories, Dr. Harper often mused on the philosophical implications. What had been forgotten was not necessarily lost. It persisted in subtle traces, waiting for patient study and careful interpretation. The ancient civilizations may not have left explicit records for us to read, but their observations endured in maps, myths, and the hidden patterns of the Earth itself. Antarctica, then, was both a challenge and a teacher, urging humans to observe carefully, think deeply, and approach knowledge with humility. Archaeological hints, combined with paleoclimatic data, painted a picture of continuity between life, observation, and memory. Fossilized plants, subglacial, microbial life, and geologic formations all testified to the same truth. The Earth's history was layered, interconnected, and partially remembered. The whispers of ancient civilizations were threads woven into this fabric, subtle reminders that knowledge could transcend time if humans listened carefully enough. Some maps even contain symbols that modern research interpreted as warnings or instructions guides for navigating treacherous ice, finding fresh water, or identifying life-sustaining locations. While interpretations remained speculative, the possibilities suggested that humans had once known strategies for survival in extreme conditions. These insights, encoded subtly in visual language, could offer lessons for contemporary exploration and for understanding the resilience of life in harsh environments. Dr. Harper also considered the broader implications for humanity's place on Earth. If ancient civilizations had glimpsed truths we had since forgotten, what did that suggest about our own relationship with knowledge, observation, and memory? Were there lessons in patience, humility, and attentiveness to the natural world that we had overlooked? The frozen continent, in all its calm silence, became a mirror, reflecting both human curiosity and the consequences of forgetting what the Earth had taught. In the end, what ancient civilizations knew was not easily summarized or proven. It existed in fragments, hints, and correlations. It was in the subtle alignment of maps with subglacial topography, in the echoes of myths that described warm southern lands, and in the resilience of microbial life that traced back to more hospitable. To understand it fully required patience, openness, and respect for the slow unfolding of time, as Antarctica itself had demonstrated over millennia. The researchers moved carefully, documenting every anomaly and recording every correspondence between ancient knowledge and modern observation. They spoke in hushed tones, aware that speculation without rigor could mislead, yet also conscious that the whispers of the past offered invaluable guidance. The continent had endured, preserving its secrets beneath layers of ice. Humans could endure by listening, learning, and slowly piecing together the story. Through this quiet process, Antarctica became more than a site of scientific inquiry. It became a bridge between eras, ancient civilizations, modern research, and the silent persistence of life, all intersected in a calm, contemplative rhythm. Knowledge, once thought lost, revealed itself incrementally, layer by layer, inviting patience, reverence, and reflection. The quiet work of modern research teams in the heart of Antarctica, where the wind sculpts endless drifts of snow and the sun hovers low on the horizon, modern research teams moved with a quiet precision. Their work a delicate choreography of observation, patience, and reverence. Unlike the dramatic narratives often associated with exploration, these scientists embraced calmness. Their discoveries were incremental, often imperceptible to the untrained eye. Yet cumulatively, they revealed profound truths about a continent that had preserved its mysteries for millennia. Dr. Harper's team operated from a research station tucked against a jagged ice cliff. Every day began with meticulous preparation. Instruments calibrated, sensors checked, satellite feeds monitored. The world beyond Antarctica seemed distant, urgent, chaotic, but within the station, time was measured differently. Here, the rhythm was dictated by ice flows, thermal anomalies, and the slow accumulation of data. The researchers understood that patience was not optional. It was the only way to uncover what lay hidden beneath miles of ice. Subglacial exploration required extraordinary care, drilling through kilometers of ice to reach lakes and sediment layers demanded both technical skill and respect for the fragile environment. Any contamination could compromise entire ecosystems or destroy critical samples. Thus, every movement, every decision was deliberate. Scientists donned sterile suits, followed strict protocols, and operated instruments with the quiet focus of artisans. The work was repetitive, painstaking, and slow, but therein lay its power. Each procedure preserved the integrity of the environment and the fidelity of the data. Even outside the station, in the vast, wind-swept expanse, the teams moved deliberately. Snow vehicles advanced steadily across ice fields, while drones flew pre-programmed patterns to map subtle topographical changes. Geophysical instruments hummed quietly, measuring ice thickness, thermal activity, and gravitational anomalies. To an observer, it might appear mundane machines worry, researchers noting readings, but to those who understood the landscape, each measurement was a small triumph, a piece of a puzzle thousands of years in the making. Inside the station, the scientists' work was equally methodical. Ice cores were sliced and catalogued with painstaking care. Each section labeled, photographed, and stored in temperature-controlled chambers. Sediment cores from subglacial lakes were analyzed under microscopes, revealing the chemical fingerprints of microbial life that had survived extreme cold and darkness for millennia. Every observation, every measurement was recorded with the precision of a scribe, forming a tapestry of data that, over years and decades, could reveal patterns invisible to any single individual. Communication among team members was quiet. Respectful and deliberate, discussions took place in hushed tones, often around shared computer terminals or over satellite links. Ideas were floated carefully, questioned politely, and refined collectively. Unlike the dramatic, headline-driven approach common in other fields, Antarctic research thrived on deliberation. Each hypothesis was tested, retested, and examined from multiple angles before even tentative conclusions were considered. The quiet work of the team was a reflection of the quiet majesty of the continent itself. Persistent, patient, and enduring. The monotony of certain tasks was offset by moments of revelation. A new microbial species discovered in a subglacial lake, an unexpected chemical gradient in a sediment core, or an anomaly in radar data could spark quiet excitement. These breakthroughs were celebrated Satalia shared glance, a murmured acknowledgement, a careful annotation in the lab log. There were no fanfares or dramatic proclamations. In Antarctica, progress was measured in millimeters, in the slow accumulation of understanding, not in headlines. Teams also relied heavily on collaboration across disciplines. Geologists, climatologists, biologists, and engineers worked in tandem, integrating data to form coherent pictures of subglacial ecosystems, thermal anomalies, and ice dynamics. A geologist's observation of mineral strata could inform a microbiologist's study of microbial adaptation. A climatologist's reconstruction of ancient temperatures could explain the presence of certain fossils. The quiet interweaving of expertise allowed the research to advance with rigor, humility, and subtle insight. Logistics, often overlooked in popular narratives, formed the backbone of the quiet work. Transporting instruments, maintaining power systems, and ensuring safe habitation in extreme conditions required constant attention. Even minor oversights could compromise weeks of research or endanger personnel. Yet despite these challenges, the atmosphere remained calm, almost meditative. Researchers moved in coordinated rhythm, each task reinforcing the others, creating a delicate ecosystem of human effort that mirrored the intricate ecosystems beneath the ice. Data analysis was another realm of quiet diligence. Back in heated labs, computers hummed softly as algorithms processed terabytes of radar scans, temperature readings, and chemical profiles. Patterns that might have escaped casual observation emerged slowly, often after weeks of computation and cross-referencing. Statistical anomalies were scrutinized meticulously. Correlations were tested and retested. Here, patience was as essential as intellect. Discoveries were not instantaneous, but their gradual unveiling carried a depth and reliability impossible to achieve in haste. The human element was equally critical. Researchers cultivated a mindset of observation, attentiveness, and emotional resilience. Isolation, cold, and the monotony of the frozen landscape demanded psychological endurance. Cohesion relied on calm communication, mutual respect, and subtle attentiveness to each member's well-being. In such an environment, quiet work was not only a methodological necessity, but a moral one. The success of research depended as much on interpersonal harmony as on technical skill. Even routine maintenance held subtle significance. Checking sensors, recalibrating instruments, and verifying satellite links were acts performed with deliberate care. These small tasks ensured the integrity of the data, the safety of personnel, and the continuity of research. Each action, though seemingly mundane, was part of a larger narrative of patience and precision that defined Antarctic science. One aspect of the work was the interplay between patience and curiosity. Researchers constantly questioned the landscape, Why did a particular subglacial lake exhibit unusual thermal properties? Why did radar scans reveal linear formations in areas previously assumed to be randomly layered? These questions were approached slowly, without the pressure of immediate answers, allowing observations to accumulate and patterns to reveal themselves naturally. The calm pursuit of knowledge was, in itself, a form of discovery. The quiet work also extended to documentation and archiving. Lab notes, digital records, photographs, and satellite imagery were meticulously organized. Each dataset became a reference point, a thread in a tapestry that could be revisited, reanalyzed, and interpreted in light of new discoveries. The slow accumulation of knowledge created a continuity between teams, allowing insights gained today to inform research decades into the future. In this way, the work of one team became a foundation for generations yet to come. Even the environmental ethos of Antarctic research reflected this quiet dedication. Teams were acutely aware of the fragility of the ecosystems they studied. Protocols ensured minimal disturbance to subglacial lakes, microbial habitats, and surface environments. Every drill hole, every sample extraction was performed with the awareness that the act of study itself could affect the delicate balance of life and geology. Respect for the environment was integral, a quiet acknowledgement of humanity's small role in a vast, enduring system. Fieldwork often required improvisation within the constraints of calm methodology. Sudden storms, shifting ice, or equipment malfunctions could disrupt planned schedules. Yet rather than rushing, teams adapted in reinforcing shelters or pausing operations until conditions stabilized. The tempo of the work was dictated not by human urgency, but by environmental realities, reinforcing the lesson that patience and respect were as important as technical expertise. Education and training formed another layer of the quiet work. Younger scientists learned not only techniques, but also the ethos of slow, deliberate inquiry. Mentorship emphasized observation over speculation, patience over immediacy, and humility in the face of an environment that had endured far longer than any human presence. In these lessons, the culture of Antarctic research perpetuated itself quiet, careful, and attentive to the rhythms of both nature and knowledge. Even moments of discovery were tempered with reflection. A new microbial strain, a subglacial river system, or a thermal anomaly prompted careful measurement and peer discussion before interpretation. Excitement existed, yes, but it was measured, modulated, and shared calmly. The process was iterative. Observe, record, analyze, hypothesize, and repeat. In such a methodical approach, every discovery became part of a cumulative understanding, each insight reinforcing the others in a slow, deliberate unfolding. Collaboration extended beyond national boundaries. International teams, sometimes working in the same regions, exchanged observations quietly, valuing precision over publicity. Shared databases, coordinated drilling schedules, cross-validation of findings reflected a culture of subtle cooperation.
Why some mysteries remain gently unanswered. Antarctica was a continent of patient silence, where time stretched over millennia and the landscape seemed to guard its secrets with deliberate calm. For modern researchers like Dr. Harper, it became increasingly clear that some mysteries were not meant to be solved quickly, or perhaps not at all. Unlike the loud clamors of human curiosity elsewhere, the frozen South demanded restraint, teaching that the value of certain truths lay not in immediate answers, but in the measured contemplation of questions. The subtle patterns emerging from subglacial radar scans, ice cores, and thermal anomalies often defied simple explanation. Linear formations beneath the ice hinted at both natural and possibly artificial structures, while microbial ecosystems persisted in ways that challenged assumptions about life's resilience. Ancient maps suggested coastlines and features that only now, with satellite technology, could be partially confirmed. Yet, despite decades of study, no definitive narrative emerged. Some mysteries simply resisted the human impulse for closure. Dr. Harper often mused that the unanswered questions were as instructive as the discoveries themselves. A subglacial lake might appear as a simple depression on a map, yet its chemical composition, microbial life, and geological history spoke of processes spanning millions of years. To attempt to label it definitively, here is life, here is no life, would be to impose human impatience upon a system whose rhythms were far slower and subtler. In these cases, silence was more accurate reflection of reality than any premature conclusion. Some anomalies persisted across multiple disciplines: geological formations that defied conventional explanations, ice cores that recorded unexpected climatic shifts, and faint echoes in radar data all suggested the existence of processes not yet fully understood. Researchers whispered hypotheses in the quiet of laboratories and field stations, sharing their ideas with care. Yet these theories were often left open-ended, noted meticulously in logs and databases, awaiting further observation rather than immediate resolution. This restraint was not born of fear, but of respect for both the evidence and the continent itself. Antarctica had endured countless ages of change, preserving hints of past climates, life forms, and potentially human knowledge long before modern eyes could ever glimpse them. Its mysteries were measured not in human decades, but in geologic epochs. To force an answer was to misunderstand the scale and to risk distorting the truth. Sometimes the unanswered questions carried philosophical weight. Why did life adapt to the extreme isolation of subglacial lakes? How had microbial species persisted through eons of glaciation? Could ancient civilizations have known more about the Earth than contemporary humans could ever grasp? The answers might exist, scattered across ice layers, rock strata, and fossils, but the process of discovery required patience, humility, and acceptance that some truths would only reveal themselves incrementally or perhaps remain permanently elusive. Even technological advancement could not hasten certain answers. Satellites could map subglacial formations with incredible precision, and genetic sequencing could reveal evolutionary history. Yet many subtleties remained imperceptible. Minor variations in ice composition, undetectable thermal gradients, or minute shifts in sediment layers could hold profound information. Yet only careful observation over extended periods could reveal their significance. Some mysteries persisted because the tools of comprehension were not fully aligned with the complexity of the subject. Dr. Harper often reflected on the contrast between public expectation and scientific reality. Outside Antarctica, people imagined discoveries in dramatic terms: hidden cities, lost civilizations, or sensational breakthroughs. In truth, the work was measured, slow, and often inconclusive. Some mysteries remained gently unanswered not because scientists were unwilling to investigate, but because the continent itself demanded a pace that human curiosity was only beginning to learn to respect. There was also a sense of interconnectedness in leaving certain questions open. By acknowledging uncertainty, researchers maintained flexibility, allowing new evidence to reshape understanding without forcing premature conclusions. A subglacial formation that seemed unusual today might later be explained by tectonic activity, microbial accumulation, or unknown climatic processes. By leaving the question open, scientists preserve the integrity of inquiry, maintaining a dialogue with the environment that prioritizes understanding over certainty. Some mysteries, Dr. Harper realized, were preserved for reflection rather than resolution. A microbial colony might exhibit metabolic processes not fully understood, hinting at evolutionary pathways that challenge conventional biology. A layer of ice might contain chemical anomalies that hinted at past volcanic activity or meteor impacts. These subtleties invited contemplation, requiring careful measurement, comparison, and theorization over years or decades. In this sense, the unanswered questions were not failures, they were invitations to deeper observation and learning. The culture of patience extended to communication and collaboration. International teams exchanged findings cautiously, noting anomalies without rushing to interpretation. Journals and databases recorded hypotheses in precise, measured language, leaving room for reinterpretation as new evidence emerged. In Antarctica, uncertainty was treated not as a deficit, but as a necessary condition for rigorous exploration, a reminder that the unknown was not a problem to be solved immediately, but a landscape to be understood gradually. Even when findings were promising, the approach remained calm. A newly detected thermal anomaly might suggest geothermal activity capable of supporting unique microbial ecosystems. Rather than issuing immediate conclusions, the teams monitored the site over months and years, collecting data systematically. Each measurement, repeated and verified, gradually contributed to a more robust understanding. The mystery remained partially unresolved, but its slow illumination offered insights far more reliable than hasty conclusions ever could. Dr. Harper also found value in the emotional dimension of unanswered mysteries. The calm acceptance that some questions could remain open fostered humility and wonder. Researchers approached the continent not as conquerors of knowledge, but as listeners and observers attuned to rhythms far older and larger than human timescales. The unanswered mysteries encourage reflection on humanity's place in the natural order, the fragility of life, and the persistence of processes that span millennia. Some unanswered questions were deliberately preserved for future inquiry. Ice cores, subglacial sediments, and biological samples were archived with meticulous detail, ensuring that even as techniques and technology improved, the potential to revisit, reinterpret, and expand understanding remained intact. The gentle preservation of ambiguity was, in essence, a safeguard against overreach, a conscious choice to respect the unknown and maintain continuity in the pursuit of knowledge. In this context, the mysteries of Antarctica were not failures of comprehension, but manifestations of the complexity of natural systems. The continent's climate, geology, and biology evolved over epochs far exceeding human lifespans. To demand immediate answers would be to ignore the temporal scale and interconnectedness of these systems. Instead, the unanswered questions were left as enduring prompts for reflection, analysis, and careful observation. There was a poetic aspect to leaving some mysteries unresolved. A subglacial river hidden beneath kilometers of ice could carry chemical traces of life millions of years old, yet its full story remained beyond immediate grasp. By acknowledging this, researchers embraced the rhythm of the continent, patient, deliberate, and unhurried. Knowledge accumulated slowly, each discovery adding context, nuance, and depth, even as the larger puzzle remained partially obscured. Dr. Harper often explained to new researchers that patience was not passive, it was active engagement with complexity. Quiet observation, repeated measurement, and careful documentation were forms of active inquiry. The unanswered questions were not voids, but frameworks within which understanding could grow. They provided structure for curiosity, focus for research, and a reminder that some truths require time, humility, and endurance. Even the most minor anomalies could become profound insights if approached patiently. Minute shifts in ice density might reveal climatic patterns. Subtle chemical imbalances could indicate microbial evolution, and faint radar echoes might hint at previously unknown geological structures. Each mystery, gently unanswered, maintained a delicate tension. It challenged understanding while resisting the imposition of simplistic solutions. The gentle persistence of mystery also fostered collaboration across generations. Data collected decades ago could gain new significance as techniques improved. Ice core sampled in the 1970s, once considered routine, now revealed details of atmospheric chemistry and microbial DNA unimaginable at the time. By leaving some mysteries unresolved, researchers created continuity, linking past, present, and future investigations in a slow, deliberate dialogue with the Earth itself. Dr. Harper recognized that these gently unanswered mysteries also nurtured creativity and imagination. While conclusions were reserved for careful analysis, speculation remained a tool for framing hypotheses and designing experiments. The balance between curiosity and restraint became a hallmark of Antarctic research, a recognition that exploration was as much about asking questions wisely as it was about finding immediate answers. The calm acceptance of unanswered questions reflected the character of Antarctica itself. The continent did not demand comprehension on human terms. It offered insight at its own pace, rewarding patience, humility, and careful observation. The mysteries were enduring lessons in temporality, complexity, and the subtle interconnections between geology, biology, and climate. To leave them gently unanswered was not a failure. It was acknowledgement of the scale and richness of the natural world. In the quiet of the field station, with snowdrifts rising outside and the distant hum of instruments filling the air, Dr. Harper and her colleagues continued their careful, deliberate work. Each measurement, each observation, each recorded anomaly contributed to a tapestry of understanding even as the larger questions remained open. Antarctica's secrets were revealed slowly, one data point at a time, encouraging reflection, patience, and respect. And so some mysteries remained gently unanswered, not because they could not be solved, but because the rhythm of discovery demanded time, humility, and continuous engagement. In the patient unfolding of knowledge, the continent revealed its truths gradually, teaching researchers that the journey of understanding was as vital as the answers themselves. The unanswered mysteries were invitations to listen, to reflect, and to honor the subtle, enduring rhythms of the earth. Reflecting on the peaceful enigma beneath the ice. As the last rays of the Antarctic sun stretched across the endless white horizon, Dr. Harper paused at the edge of the ice shelf. The wind whispered softly, carrying with it the faint crunch of distant glaciers and the quiet hum of research instruments within the station. It was a landscape both harsh and serene, imposing yet intimate, a place that had preserved its mysteries with a patience unmatched anywhere else on Earth. Here, she realized, lay the essence of the continent's enigma, a peaceful world that had endured millennia, revealing its truths slowly, gently, and in ways that demanded both respect and reflection. The journey to this understanding had been long and deliberate. From the silent microbial ecosystems thriving beneath kilometers of ice to the subglacial lakes warm enough to sustain life, from ancient maps hinting at coastlines long buried to the faint traces of civilizations that once might have understood the Earth's secrets. Each discovery was a quiet reminder of patience, resilience, and the subtle continuity of life. Every step of the research, careful observation, meticulous measurement, and cautious theorizing had contributed to a slowly unfolding tapestry of knowledge. Standing there, Harper thought of the scientists who had preceded her. The early explorers, guided by curiosity and the promise of uncharted lands, had glimpsed fragments of the continent's mysteries. Their observations, recorded in journals and sketches, were humble beginnings that modern researchers had expanded with satellite imaging, ice core analysis, and subglacial sonar mapping. Each generation had built upon the last, approaching the unknown with a quiet reverence, always aware that Antarctica revealed its secrets not in haste, but in its own time. She reflected on the microbial life that had persisted in eternal darkness, surviving in lakes beneath ice sheets, isolated from sunlight and warmth for thousands of years. These organisms were living testaments to resilience, evolution, and adaptation. They reminded her and her team that life, in all its subtle forms, had a profound capacity to endure. Observing these creatures had changed the way she thought about existence, extending her understanding beyond human timescales to the patient rhythms of the natural world. Antarctica's ancient climate, too, held lessons. Evidence from sediment cores, fossilized pollen, and geological formations suggested that this frozen expanse had once been temperate, even habitable. Forests might have flourished, rivers might have flowed, and ecosystems thrived in a manner unimaginable today. The thought that human memory had lost much of this knowledge while the Earth itself retained every record was humbling. Modern explorers were merely guests, interpreting traces left by eons of geological and climatic transformations. Dr. Harper's gaze drifted to the ice cliffs that rose sharply behind her. Layers upon layers of ice told silent stories, winter after winter, year after year, millennium after millennium. Each striation was a record of snowfall, temperature, and atmospheric composition, a frozen archive that scientists could decode if they approached with care and patience. She realized that these layers represented continuity, a tangible reminder that while human lifespans were fleeting, the Earth's processes endured, and understanding them required both diligence and humility. Her thoughts turned to the ancient civilizations that might have once held insights about the world now lost to modern memory. Whether their knowledge was encoded in maps, myths, or symbolic systems, these whispers from the past demonstrated that curiosity and careful observation were timeless human pursuits. The link between humans' fleeting presence and the continent's enduring enigma was profound. One reminded the other that patience and reflection were as crucial to understanding as intelligence or technology. The quiet work of her team had been central to these revelations. From meticulous ice core analysis to careful monitoring of subglacial lakes, each action was deliberate, purposeful, and patient. There were no dramatic leaps or sensational claims, only slow accumulation of evidence cross-verified and recorded with precision. The calm, deliberate approach mirrored the pace of the continent itself. In Antarctica, knowledge unfolded in increments, never forced, never rushed. Some questions remained gently unanswered, and Harper understood why. The anomalies, the formations, the microbial ecosystems, and even the whispers of ancient maps resisted immediate explanation. Their mystery was part of their allure. To accept this uncertainty was to honor the integrity of the scientific process and the scale of the environment in which it took place. Here, in the quiet vastness, the unanswered questions were not disappointments. They were invitations to wonder, reflect, and continue observing. Harper thought of her colleagues, each immersed in their own meticulous tasks. Calibrating instruments, analyzing sediment, monitoring thermal anomalies. The teamwork, quiet and deliberate, was a testament to human dedication and collaboration. Together, they created a living dialogue with the continent, balancing curiosity with restraint, exploration with care, and observation with humility. It was a model of how knowledge should be pursued, patiently, collaboratively, and with reverence for the natural world. The calmness of Antarctica extended beyond its physical landscape to its lessons in perspective. Here, the relentless passage of time dwarfed human endeavors. Ice that had formed over millennia, microbes that had persisted through glaciation, geological formations that had withstood tectonic shifts, all demonstrated resilience and continuity
far beyond human comprehension. In this context, scientific work was not about conquest or domination, but about listening, interpreting, and slowly weaving together fragments of understanding into a coherent narrative. Dr. Harper's reflections extended to broader philosophical questions. What did it mean to seek knowledge in a world that demanded patience? How could humans reconcile curiosity with humility, ambition with restraint? Antarctica's calm enigma offered answers through its very nature. By preserving life, recording history, and revealing truths only incrementally, it taught that some of the most profound lessons come not from immediate understanding, but from sustained attention, contemplation, and respect for scale. Even the landscape itself encouraged reflection. The ice, stretching endlessly, reflected light in ways that seemed both stark and ethereal. Shadows shifted slowly across the crevasses and ridges, reminding observers that time in this place moved differently, measured not by clocks or calendars, but by seasons, snowfall, and the quiet evolution of glaciers. This was a world in which human impatience could only hinder understanding, only calm observation.
Harper considered the mysteries that had captivated the imagination of generations. Subglacial lakes teeming with microbial life, geological formations that hinted at ancient events, and the possibility of climates that had once been warm and habitable. Each enigma was a reminder that discovery was a process, not a destination. The continent demanded respect for the slow, patient unfolding of knowledge, a lesson that extended far beyond Antarctic research into the very way humans approached the unknown. As she looked across the expanse, Harper realized that the true value of Antarctica lay not in solving every mystery, but in the relationship it fostered between humans and the Earth. It was a dialogue built on patience, observation, and reverence. Researchers were not conquerors of this frozen realm. They were its listeners, recording its subtle messages and translating them into understanding for those who would come after. The lessons of the continent extended into everyday life as well. Antarctica's calm, measured rhythms reminded Harper that some questions were worth pondering rather than rushing to answer. Some truths could only be appreciated in fragments, each layer of observation adding depth and context. In a world increasingly dominated by speed, instant results, and superficial knowledge, the quiet enigma beneath the ice was a powerful reminder of the value of patience, reflection, and respect for the larger rhythms of existence. Even as technology advanced, the essential approach remained unchanged. Satellites, subglacial radar, automated sensors, and sophisticated laboratories enhanced human capability, but they did not replace the need for careful, thoughtful interpretation. True understanding depended on humility, methodical observation, and a willingness to accept that some questions might remain open, unanswered for years or even centuries. The peaceful enigma beneath the ice demanded no less. Dr. Harper felt a deep sense of connection with the generations of scientists before her, those who had moved quietly across ice fields, mapped ridges, extracted cores, and documented anomalies. Their collective work, patient and deliberate, had built a foundation for understanding that was as subtle as it was profound. Antarctica, in turn, had revealed its secrets gradually, layer by layer, encouraging a calm, thoughtful approach to inquiry that honored both the environment and the processes it preserved. In her final reflection, Harper recognized that the continent's greatest gift was perspective. It reminded humans of their place in the vast timeline of Earth's history, the endurance of life under extreme conditions, and the subtle persistence of knowledge across generations.
The peaceful enigma beneath the ice was not a puzzle to be solved quickly. It was a teacher, a silent guide, and a mirror reflecting the patience, humility, and curiosity required for meaningful understanding. And as the Antarctic sun dipped below the horizon, casting a soft glow over the endless ice, Dr. Harper understood that the calm majesty of the continent, its mysteries preserved through millennia, would continue to inspire, challenge, and teach. The subglacial lakes, microbial ecosystems, ancient formations, and echoes of long-lost climates all spoke in a quiet voice, inviting humans to listen, to reflect, and to appreciate the enduring beauty of the unknown. In its frozen expanse, the earth whispered truths older than civilization itself. Truths that could only be understood by those willing to listen to the calm, measured heartbeat of the planet.